So in the Google Meet, it is getting truncated for some reason.
So maybe in a couple of minutes we can start.
Yeah, I guess we should get started, Dr. Alok. Yeah.
So we'll open, you can open and then you can take it from there. Just introduce and talk about the content.
Yeah. All right. Okay. Very good morning, everybody. My name is Subhash Mandal. On behalf of COMSOC Bangalore, I am doing this opening remark as Dr. Gana is not able to join in. As the topic says, this workshop is about open source in communication. The open source has become a very, very important factor into the success of today's communication products and solutions. And the workshop is organized to bring in awareness to the attendees about different initiatives that is taking place in the overall ecosystem as far as the communication industry is concerned. We have very distinguished set of speakers in this workshop today. The session agenda is listed here. We are starting now, and we will intend to wrap up by 1:10 p.m. The agenda of the session is going to be...
Subhash, just sorry to interrupt. Is the streaming on?
Yes, it is.
Okay.
We start with the trends in open source in telecom. That Dr. Aloknath Dey is going to anchor that session. As you know, Dr. Aloknath is the chair of the Communication Society Bangalore chapter, and under his leadership we recently also have been recognized IEEE worldwide as one of the best chapters. And then this will follow by a session by Dwarka Prasad from Samsung R&D. He is going to talk about the runway of open source, success mantra and challenges, followed by a session by Kashif Khan from Nokia on ORAN and the way forward. So this session is going to talk about the open radio access network in the era of disaggregated 5G network. Followed by that, there is a session on ORAN intelligence framework by Avinash Bhatt from Samsung, followed by a session on networking at the speed of development with OS API by Subodh from Cisco. And then it will move into the cloud native framework with Kubernetes OpenShift for 5G network by Vinay from Red Hat. And then we will conclude the session. So with that, I would request Dr. Alok to talk about trends in open source and telecom, please. Dr. Alok.
Yes, thank you, Subhash, for the introduction and today's workshop agenda. So first of all, again, let me have a hearty welcome to all of you to this Saturday morning sessions for 3 hours. And IEEE Bangalore sections, the COMSOC, welcomes. We have been doing a lot of different workshops. This year has been very effective, very eventful, whether it is 5G, Wi-Fi, quantum computing, many different topics that we have covered throughout the year. Not only that, many student programs and industry university interaction has been a strong agenda for us. Particularly this research methodology Dr. Naveen started and how to write papers effectively. We had recently a session. We also did a how to file first patent this year as a first program. And this open source is also something that we are going to take it very seriously, and this is a first initiative towards that. So with that note, I will start my own presentations today to talk about trend in open source and in telecom. So I think to get the whole space, probably I'll turn off the video and just stay focused on the slide deck. So Dwarka, you can handle it. So the first slide, we are talking about why open source. I think each company, if you look into this in the earlier days, people could do a fast following, faster executions, and be successful. What we have seen in early this century, that the innovation is becoming very, very important component. And the whole last decade, particularly in India, we have seen how digitalizations are making wave. And that's the first level of innovation that's happening. But this century, the second decade or third decade, as we are starting from 2020 to 2030, it will be quite a lot about deeper tech. Not just deeper tech, but also how you can augment this in-house innovation with an open innovation. So this collaborative and faster innovation, obviously open source is one of the avenue, not the only avenue. You can work with universities, you can work with startups, you can work with other companies in much more direct fashion. All these are kind of open innovation. The reason for that is you can build with multiple brains globally. And as you do that on the innovation front, same way, more hands are available than your organization to do reduced time to market for your delivery. And then this whole process brings a lot of transparency. Think, discuss, decide together. So this is at a macro level, first set of benefits, why open source. But then as you go deeper, you will find, we can make solutions much more vendor agnostic. We don't need the specialized hardware we can run. We can improve our security level. We can make things modular and maintainability goes up. So there are many different angles that would come through this open source. So if you go to the next slide, then I talk about some of these steps that are coming. So let's look into some of these trends and big companies. So is it a small player's game? Is it just a fad? Look at it. IBM closes landmark acquisition of Red Hat for $34 billion. This defines open hybrid cloud future, multi-cloud kind of scenario that IBM is conceiving. How do you define the APIs and make it open so that not just one set of cloud, something you can run in one cloud, some others could be in another cloud, and you can still get the whole solutions. So that's $34 billion acquisition. Microsoft finalizes $7.5 billion GitHub acquisition very recently. Right? Salesforce signs a definitive agreement to acquire MuleSoft. So this gives you an idea that it's not just a small player game, it's a big game, big players, big numbers for acquisitions, and some cases maybe investments. I just flashed a few such investment trends. Now the below, when you look into that, so it is not just telecommunications area. The first pillar talks about IoT, edge, and I have a detailed slide for that, so I'll skip for now that vertical. Let me delve into the other applications so that we understand that it's not just the telecom. Telecom is a pioneer because we make a lot of contributions. Certain ICT technology would play a role in various services. So if you take the financial services, the FinOS, FinTech Open Source Foundation, this interactive visualization component for large real-time data sets. And you can use the reporting very easily. FinOS has a legend, a flexible platform that offers solutions to explore, define, connect, and integrate data into your business processes. So this is one example, and this is all from Linux Foundations. And if you look into Linux Foundations, the members that are playing, the Citibank to Deutsche Bank to JP Morgan, GitLab, all these are part of this FinOS stream. Let me take the third pillar, which is retail. And you have many of them, but let me just take one, Odoo, which is an open ERP plus CRM solutions. Your e-commerce, the billing, the accounting, the inventory management. All these are covered. It's a business management software. Now, when you do that, one question obviously comes in mind. What kind of coding language do you use? So typically Python, JavaScript, XML, at least for Odoo, I'm giving examples. Those are being used, and similar languages are being adopted in other open source. Now, when I say open source, don't get a wrong notion that it is not always free source. So there are licensing terms. And I believe Dwarka is going to cover a lot about how this process would be followed and what kind of licensing technologies that are there under different software streams. Now, if I go to the next, which is film and entertainment, we don't expect that. They are a different world altogether. But in 2018, Academy of Motion Picture Arts and Science has started, this Academy Software Foundation. Code, collaboration, creativity. This is all for animation and visual effects. That's a very new world, and even they are adopting the open source, point to note. Then I talk about semiconductors and embedded systems, open power ready. There is semicon to enable the ecosystem product development. There is a minimum characterizations that are defined in one product. How can it be compatible to the others? That's what they look into it. Yocto is a project on embedded Linux. And again, it's not just one particular layer. You can do sometimes open source on a specific layer. And this is the good example where TI, Intel, Xilinx, Microsoft, Mentor, maybe ARM, they all are part of it. For embedded system development tools, so that you can have and create a custom Linux-based systems, deploying connected edge devices and virtual devices and servers. So I tried to give here different examples that it is not just telecom, it's all these verticals, they are adopting and transforming themselves, and overall big acquisitions and investments are happening in this space. So if you go to the next slide, then I talk a little bit more just to make the point a bit stronger. Some news from open source. And you see Murphy's hockey law is the hockey stick exponential growth, the open source services market. As you make the software much more modular, API driven, the services market also open up, because you can have one component, somebody wants to build a part of proprietary software, take an open source piece and build something around it and deliver. So the services opportunity also grows. And we can see astonishing growth by 2026. That's the predictions, and Red Hat, Accenture, Wipro, they were in the news in this context. Then you see on the right side, Marvell introduces chips for open source 5G networking gear, right? Even at the chip level, I give the examples, and they are designing to let telecom carriers mix and match equipment more easily. You take one piece of the equipment from one vendor, but you can take it from another vendor. Even if you have today from the same vendor, tomorrow you can replace, or vice versa. So that's the real benefit why so many people are coming into picture, because the software has been written and open source is very much there in some form or the other. But what is happening is it's getting much more structured, layered, and opened at the interface level so that this mix and match can continue. OpenSSF technology and enterprise leaders combine the efforts to improve even open source security. And Finextra, the banks are finally embracing the open source movement. Banks are typically slow on the software adoptions. Many of those, their software still, we know in the Y2K time and even otherwise, it's quite archaic because a lot depends from the customer standpoint. So they can't change. They're like automotive segment equivalent in the space. They take time, but even there, they're embracing this open source movement. So as you can see, the services, the security, the modularity that I talked about, everywhere, it's kind of sipping in, and I believe it's good time for India to also join and participate into this movement. And that's our intent for this sessions, to kind of kickstart from IEEE side, whatever contributions we could make. If you go to the next slide. Here now I talk about the open source in telecom. So yes, it provides an immediate feedback loop for defined standards. Now, one question that comes, and very recently in the IEEE TANTs, we will be having a particular sessions where we are talking about open source and standards, the relationship. TSDSI is driving, so I'll be also part of that. And this is very, very important to note, because telecom world has been driven by standards. Now, if you look into audio video codec, they were already doing some reference C code, like they used to call golden code. So it's not new from there. The standards are being defined, and you get a reference C code. Now, if you want to build your innovation further around the standard, you can take this C code and or whichever language, the golden code, reference code, and then you can make your changes and make sure finally bit compatibility and other kind of things. Only thing that's coming, it was just at maybe codec level, but here we are talking about the full stack. And there, even though the reference code was there, but now I can still split that into multiple segments. And what it does, I will show an example that how this is going to help the open source and the standards, because standards are becoming complex. And to validate, to verify, if you have this open source on the sides, it is much easier. And you can get a feedback, vice versa. Is your reference code, open source code, complying fully in the standards? You can check that. Or go back and say, no, this doesn't work. This is where there is a deadlock or certain things, and you can change your standard definition. Significant cost reduction in running a network, because you can take standard hardwares and from different vendors, cost-effective vendors. And we can see that it's becoming much more software-driven, less hardware. Very powerful hardware. I don't mean to say it's any less, but standard hardwares and powerful hardwares, remote data centers, but a lot is going to be defined by software. So more software, less hardware, enabling quick launch of new capabilities in service. And we can see that can strengthen security and safety across this deployed network. So we see here in this, there is a mobile, residential, your small, medium businesses and enterprise at all levels. Linux Foundation could address. Now, I have mentioned here quite a good number of different open source standards. or open source communities, whether it is open access level, edge level, or core and cloud. Now, I don't intend to cover all of them, but just to introduce a few, and rest I'm sure you would be hearing through the subsequent presentations. So Linux Foundation itself is a non-profit technology consortium. If you are not knowing, it started in 2000. I think it aggregated some open source development labs and some free standards group, and they formed it, and there is a long journey since then. And 100 plus projects are running in there, and estimated development cost would be no less than $16 billion that I know. So here we have these elements of homage. Let's take that. And homage is doing the edge computing services ecosystem and users with interoperable, flexible, scalable computing server platform, right? With a set of APIs that can run with libraries and routines, runtime. So what happens in digital appliances at home and devices that you have, they will be considered nodes. And then you have homage orchestrator. And this orchestrator can add a device, assign as a node, and then configure, and all kinds of service discoveries and things like that would happen through this. A similar thing downline in the open edge area, you can see a Crino edge stack. That enables a similar thing to the home edge, but it widens the applicability. It goes into your connected car, the AR, VR, and the telco access edge. This is an entry point from that angle, and quite independent of your hardware, silicon, cloud, or operating systems. That's the role it's playing. Then on the top, on the open access, you see ORAN. This is a very hot topic, and we have two speakers today, so I'm not going into the details, but the whole journey from RAN to ORAN is very interesting, how it evolved, and AT&T and Deutsche Telekom, and it's a disaggregated approach, as we said, to deploying mobile front-haul and the mid-haul networks, and quite a lot built on cloud-native principles. So yes, I think we will hear how this journey from 3GPP's release 15 to this ORAN alliance, where I believe about 150 companies have been working, and they're splitting into some parts as distributed unit and some as central unit. And then you can take the control plane and the user plane effectively and build this. So more, I think, the presenters will highlight. Similarly, we have the ONAP, Open Network Automation Platform, right? Driven by policies. It has orchestrations, automation, physical and virtual network. Finally, it does, a rapid automation of new services and overall a complete life cycle management. You can say that. That's the purpose of that. And you can have like OpenFV also into the compute, storage, and network function virtualization on the side. Two others I'll just take name here. One is the Acumos AI. So as we all know that 5G and beyond 5G, already people are starting to put some of the AI, and the whole 6G journey will happen. AI will play a very significant role. People are already putting AI, but then it's just in the specific areas where we can do it, but it's not built that way. So I think the next level platform and open source framework like Acumos AI, it will standardize the infrastructure stack and components and run some kind of out-of-box AI, right? It's like an AI collaborative framework. You can say, if you want to do that, you can do through this structure. Kubernetes, scalable, secure software. Is that open source for automating deployment, scaling, management of containerizations. And I think we have, we have Vinay who would be speaking on this topic, and we'll wait for that, how Kubernetes is providing software solutions in open source fashion. So I think this is a broad picture in the context of 3GPP, in the context of Linux Foundation, in the context of homage and going out to the outside world to edge stack, going to the core networks. If you go to the next slides. So the next two slides I will cover, and that will be the crux of my presentations in the IoT context. So yes, I gave example on the 5G, and before that in other contexts, let me just have 2 slides more to explain how things are evolving in the IoT context. So from Samsung, we already have a SmartThings platform, and it has a cloud, it has an applications, and we're building the edge. So device can directly connect to the cloud, can go through the hub. But the interesting thing is cloud to cloud. Because if I have a smart home, I'm operated on a particular cloud, but maybe next door there is a, from my smart building, and next door there is a smart parking lot. And that's operated by another vendor, service provider, and they have a different cloud. Now, when these two clouds talk, initially we also started with proprietary definitions. But OCF, Open Connectivity Foundation, this is something, we have about 400 plus companies participating globally on this. And I'm very glad to say that, we opened this chapter, India chapter 2 years back. So I am chairing, but also NASCOM is the secretariat. And we have worked with India government as we have defined in India one M2M as a standard for smart city, but smart home and building is OCF that will be adopted, and they can interwork. And we are about to sign some MOU between the smart city example and smart home and building, how we can share information from one M2M to OCF and OCF to one M2M. But coming back to this, so now we have defined your stack, IoT stack can have many elements, different connectivity technologies of Bluetooth or Wi-Fi or NFC, you can name it, UWB will come. So all those technologies are existing. And then you have the middleware of your device and service discovery. But finally, once it reaches to the cloud, one cloud will talk to the others, and that's where we are defining the C2C connector. So one cloud would have that C2C connector, the others are defining this open API. And this recently we have launched through OCF globally called Unified Cloud Interface. And there are a couple of products, Samsung and few other companies have either trying or got certifications, about to get into that stage of UCI certification. What does it do? Because this can operate in one account, and that may have another service provider account. You can link, there is API to initiate, remove the link. You can have device API, single or all device discovery, retrieve and update the resources. And even events API, you can do, because when something happens in one cloud, you could take that event and say, I have another device to operate, and I will do that. If the door lock or some surveillance camera is, the service is being provided by one, but yes, if something goes wrong, you may like to hand over or give an event for other devices to. If you go to the next slide. Yes, so that's defining this. We can have a better diagram, but just it will illustrate here, the network interface is below, the Wi-Fi, the thread, and the Ethernet. that can be the interfaces. But as I said, the connectivity technology can be anything: Zigbee, Z-Wave, BT, BLE. It works with all. You have middleware, where data management, device discovery, service discovery, security, all these are defined, like what I have shown: credentials, access control, the TLS kind of mechanism. And interestingly, this OCF resource model is very, very vital. This is about device characteristics, like a light from one vendor could have just an on and off switch, whereas maybe another light I can also dim at 10 different levels, right? Or I can change color. So if I have to define light as a category, then I have varieties of capabilities of changing color, to changing level of intensity, to changing even maybe, other kind of configurations. Obviously, on and off are basic. So this allows all to be defined, and you can operate from the clouds in a multiple different ways. And it's called capability model, the resource model or the capability model. And there is this APIs and language bindings through which this communication happens. And it's true for any application, so whether it is healthcare or building or smart home. So some places OCF is playing bigger role than the others. Now the key point why I explained is this is the IoT stack from Linux Foundation. This was built as an open source code. And what you saw the previous slide is the standard interoperability standards in some sense. And they went hand in hand. This is exactly, I took time to explain this, which is a little different topic, but the key message to take from today's presentation is that if we can build side by side, then we validate standards, and standards contribute to open source. Huge number of people are contributing into this IoT stack building, and even on the UCI interfaces. So with that, I come to my last slide, the next one, which is giving a little bit of Samsung's journey, what we have been doing. And I'm sure some of the other presenters also will touch upon it. Starting, as I said, 2000, the Linux Foundation. So we also started working at quite early on. In 2009, you can see some of these Galaxy Smart TV, Exynos that we came in. One of the big things we did is Tizen operating system. And in India in 2015, we even launched some smartphone people, feature phone people to move on to smartphone. For a couple of versions, we did this Z phone. But our intent has been to use Tizen for IoT devices. And I believe we give a time like 2020 this year to make all of our digital appliances IoT compliant, and they are based out of Tizen. Most of our TVs and washing machines and fridge, and Tizen has multiple profiles. This is also an open source, and it has a macro level profiles, like a bigger devices like fridge and TV, they can use it. You have some middle level things that is quite amenable for wearables and phones and this kinds of mobility devices. Then you have a micro profile, which is also good for small sensors and devices. That's how we started the journey and took it. And we did a big event to start that in 2015. Then moved on to IoT. I talked about OCF chapter. We have about 60 members now, roughly in India, who are working on OCF for smart home and building. Going forward, the Ajax Foundry, that's for factories, quite a lot, the Edge Solutions, the ONAP I mentioned, moving more 5G AI robots. So ROS is the robotic operating system. open standards. Moving to the LFAI, I give example of the Acumos AI, and so that's AI collaborative framework. And ORAN and ONAP, we will talk about that. Going to even the codec, MPEG 5 and it's beyond EVC codec that are coming. They're also kind of open standards in that sense. Then CNCF and OpenSSF bring security and cloud native dimensions in a big way. So as the technologies are growing, more and more numbers of open source bodies are under Linux foundations, different working group, different projects are starting. We are quite in sync. Yesterday in LinkedIn, I put an article also from Samsung Next, who has talked about why open source and also some of the investments in startups that we've been able to make and how they are working in this. For example, Signalware is a company who does this free switch. You can convert your computer to a telecom switch. And similarly, I think there is EdgeWorks and others. You can read that article. And the event, our own event is called SUSCON. So that's a Samsung open source conference that has been going on from 2014. And I hope if we have enough interest, then we can even organize, we can try to do that in India one time. So with that, I have tried to cover why open source, different fields in telecom, particularly 5G, 3GPP's release, how it's growing, and specifically where I'm personally involved from Tizen to IoTPT, some of these IoT linked open source. So I gave examples for that. With that, I'll stop here and maybe Dwarka can also present because he will take us through some journey of how to get there, and we can take questions after that together, or if you have quick questions, I can take it. Thank you.
Thank you, Dr. Alok. I guess we'll take the question at the end. So, audience, please keep typing your question into the chat box. It will be taken up. So, Anindya, you wanted to give some points to Dwarka for the presentation to be better visible.
Yeah, Dwarka, can you just present your screen, because I think people are having difficulty on YouTube seeing it.
Yeah, I just stopped sharing after Dr. Alok's presentation. I'll share my screen now.
Yeah.
Okay. Good morning to everyone. Thank you, Dr. Alok, for setting up this stage. It was really insightful. And I think it was also a good warm-up for everyone to understand why is open source so important and why is industry so much interested into this open source type of projects. So without wasting the time, I'll just move to my presentation. I'll switch off my video and focus on the presentation going forward.
Yeah, Dwarka, you can be in slideshow mode actually. Yeah.
Thank you. Okay, I hope everyone can see my screen.
Yeah, I think it's perfect.
Thank you. As the title says, Runway of open source. While I was working on this presentation, I was thinking on what could be the good session for everyone. As Dr. Alok mentioned that in past couple of IEEE sessions, there were sessions where we did some paper writing, we did some other innovation related activities where it was more about learning. And it is always great to share the experience with the industry and grow. There's always the knowledge increases when you spread the knowledge. So here I'm going to present what exactly the journey looks like for an open source project. Right from a start of an open source and how it flies high. What are the reasons it might crash land? Apart from that, if someone is interested to join an existing open source, what are the factors a person should look into? If there are certain risks involved in it, I'll go through that at a different stage. A little bit about me. I'm with Samsung Research Bangalore. I'm an innovation program manager, driving and managing an advanced technology lab here. So let's go to our runway. This is how a runway will look like today. It's really interesting way of how I thought about to present it. It's just like a runway of our aircraft that we see at our airports and other places. We will start with different steps, the way the aircraft starts cruising at a different speed to make sure it is able to lift up and fly high. So let's see step-by-step approach on each milestone. What are the things necessary? What are the do's and don'ts at each step that we should be careful? Before I move to next slide, I would like to just add one more thing, that this is more about the learning. So you might not get more technical things here because we have other good sessions where the technicalities will be displayed. Here it is more about understanding the open source concept itself, the fundamentals. So moving to next slide. First milestone. Why and what? It's a very common question for anyone who generally starts a new project. But in open source, how do we answer these questions? First step is charter. Well, the charter is very common. Everyone knows what exactly charter is. But there are many incidences in the industry where people actually make mistake here. Charters are getting confused with the technical details also sometimes. That's not the way open source projects are started. For an example, if I have to start a lightweight IoT device open source project, it should be in a simple English which can be understood by not only technical guys but also non-technical guys. Because in open source industry, we have both the type of engineers and experts involved where you need excellent communication skills as well as you need excellent coding skills. So that's the reason the charter has to be in a simple English. Coming to an example of lightweight IoT device, it could be something like this project or the goal of this project is to develop an open source which will expand an ecosystem or set up an ecosystem for lightweight IoT devices for home or for industry. It need not be too detailed because the details can come in other set of documents and other set of places. Charter should not be misinterpreted or misunderstood by bylaws or any other legal implications. Charter is just a simple few liner. So that's the first step. That actually answers why exactly this project exists. What is the purpose of this project? Moving to the next step, alignment with company's vision. Why do I bring this step here? As Dr. Alok mentioned and also shown in his slide, there are big players involved in it. What does that indicate? It indicates that most of the mega projects happening are driven by corporates. And when we say driven by corporates, it's very important that the charter or the purpose has to be aligned what company is imagining down the line 5 years. What they expect, how much investment are they really able to afford? Because while open source, people think it's free, but in some sense, it's actually not free. There are, not really like a monetary basis, but there are ways somebody has to actually invest in it. It could be a time, it could be a resources, or multiple other items over there. Hence, alignment with one's company's vision is extremely important at this stage. If we miss this thing, there is likelihood that probably we might even crash land in between, or in software language we might encounter an hygiene bug, which we may not have even thought about it at the early stage. So once we are aligned with the company's vision, the next thing comes is roadmap. I understand that for some open source project, it is extremely difficult to have a really long-term vision, but one still needs to have a short-term and a mid-term vision so that people who visit your project, people who hear about your project, they get to know what is your intention. Let's take an example. If I say that I am going to have a liaison with a couple of SDOs, well, which SDOs? What type of SDOs are you looking for? Or let's say that I am going to make sure that my open source project is interoperable. What does that mean? It means that I might be providing a certification program down the line, but when? 2 years later, 3 years later? What are the requirements for that? So coming to the point, the roadmap is important in terms of giving the visibility and the potential of this project. You need to have your feature roadmap, you need to have your partnership roadmap, you need to have your certification roadmap in place. If this is not available or this is weak, even if the project is good, one might think that this project may not fly high. Once you have a roadmap in place, the last step in this slide is extremely crucial. That's management blessings. As I mentioned at step 2, if the purpose is not aligned to company's vision, and if company is not intended to invest heavily or even a little bit of it consistently, there are chances that your engineers may be pulled out and that project might become zombie. You search on internet and you may find many such projects which started, which had an excellent purpose, which was having very innovative technologies in place, but 2-3 years later they just stopped. Only reason is because the resources that were investing their time were working with some corporates, and corporates decided to just do away from it. Probably their vision got changed. So it's important that we get management blessings, or I call it blessings, but it's generally an approval, saying that what exactly you're expecting from this project, and management agrees that fine, no problem, we can go ahead. Because management might expect multiple things, which we'll talk about in next consecutive slides, subsequent slides, is that the royalty things, licensing, multiple things are involved. So there could be questions and that needs to be answered to get in management approval. So moving to the next slide, by assuming and understanding that we are clear with why and what, we have a project in place and ready to fly. The most critical and expensive step, as Dr. Alok also mentioned, that there are implications when it comes to word license. I call this slide Riskometer. I divided this slide into 3 parts with low, medium and high risk, the level of risk. Let's start with the most favorable risk, that is item, that is low risk item. One of the highest favored license and utilized license in the industry, in open source industry, is MIT. And the second highest is Apache 2.0 these days. Why are they favored? Why do people like to use those licenses? The reason I'm putting them under the low risk category is because you are allowed to use either as is or refactor it and modify it, no problem, you can commercialize it. The only requirement they have is you keep the license file and the copyright notice in your project public. Either publish it in your device or on your website, so that if anybody is interested to know which open source you have used, they can get to know from it. That's the simple thing. There are no legal implications, even there are no patent issues at this level. There are of course many more other licenses. I have picked up those which are heavily used. Now moving to the next one, which is little bit favored, but there are risks involved in it. Let's see what are those at the medium risk. At the medium risk, it's I call it medium risk, but industry calls it semi-permissive license. Now, what exactly it means by semi-permissive? In the low risk category, it was more about permissive because everything was allowed to do. In the medium risk category, the license that you see, there are situations where the author of the project may ask you to open the code if you have modified something in the open source that you have used. But it's not mandatory, it's case by case. So one has to read the license document very carefully. And I personally don't recommend that engineers should read, because the language used in license document is not easy to understand. It is always good that the lawyer or an IP expert reads the document and gives the advice, what are the stronger statements made in it where we may face a problem. one might even land in a situation that they might have to pay a royalty on every device sold in the market. Hence, it is called semi-permissive. Why? Because it may or may not. That license may be a permissive license as well if they haven't added any stronger statement over there. Now, the last one in this slide is the high-risk licenses. We all know GPL and LGPL. I am sure everyone has used it. The very famous example is Linux itself. Linux kernel is a GPL license, as we all know. If you try to modify something, you will have to open it up. There are many such cases in the industry. While it's a high risk, but still some players prefer this license because of two reasons. One is they want that if you modify, let the industry utilize it. Let the society get the benefit of that changes. Second thing is, some companies are actually in a favor of making business. They would like to monetize on whatever they have open sourced. There is likelihood that some patents are hidden in that source code, that the moment you use it, you will land up in a situation where you will have to start paying some royalty. An example of this case, if everyone is aware, there was a situation a couple of years ago when XML patent was found in Android, and companies who were producing Android phones were asked to pay the money. There was one more case around Linux Ethernet module, where an European author suddenly came running behind the companies asking, please pay me a couple of $1 million, else stop using it. Now, paying the money is fine, but the problem happens is it can tarnish the brand. If you make a mistake, it can actually jeopardize the whole project, as well as the products might start failing in the industry. So we need to be careful. I have picked up very selected licenses in this slide, while there are hundreds of licenses available. Just remember that we need to go with mostly the low risk licenses as much as possible. Now, coming to one more point in this slide is, if you are interested to consume the open source, if you are interested to not to start a new open source, then yes, you should be on the low risk license side. But if you are starting a new open source, then it is important that if you are expecting to have a bigger ecosystem of developers, bigger developer community, you want people to like your project, then you should always be between low and medium. The moment you go towards high, your marketing cost of project will be increased, because you might have to invest a lot to bring in players to actually join, because people will start asking questions on why should I even join that project. So this slide is, that's why I mentioned it's critical and expensive, because if you make a mistake here, you might land up paying a huge amount as well as closing the company at some point in time. Moving to the next step of our runway is the governance model. Well, the word itself indicates that it's something coming from political systems or the government systems around the globe. The words and terminologies used here are very much closer to the government systems that we have in either in US, Europe, or anywhere else. At different stage of project, when you're starting a project, or when the project is already at certain stage, what are the type of governance models we use? Let's see. The first one is benevolent dictatorship. I'm sure everyone must have heard this word. It's a very common terminology in US. Whenever a project is new, let's say that you're going to start a project today, it's always recommended, I'm not saying it's like a strict rule, it's recommended that you follow benevolent dictatorship because you have set the mission. Your vision is set. You would like that project should reach certain stage. Until that point, you would like to control it. While you should be open to listen to community members, developers, feedback, bugs. But at the end of the day, any major changes to be done in the roadmap or to the project architecture should be done by the original author of the project, so that your first milestone, your first key achievement is achieved as per plan. many projects fail because they start receiving ad hoc requirements at early stage. They actually forget that the mission was something else. So that's the reason at the early stage of project, it's better that the founder takes the decision appropriately, but I would also recommend that it should be diplomatic. Now, assuming that a project has reached certain milestone, they have achieved certain goals, then you can enter into the second governance model, which is called meritocracy. It's generally applied for the stable projects or the project which is at an intermediate stage after reaching certain goal. For an example, Dr. Alok mentioned about IoTVT. He spoke about homage. They have released multiple versions. So after 2-3 releases, it's good to enter into meritocracy because you are stable. It's right time to invite more people to join your board of discussion, to board of decision making. Let the decision be democratic. This will actually help you to proliferate for that project. Now there is one more third one which is very unique and which is commonly used. It's called foundation backed. In the previous presentation, we had heard the name Linux Foundation. There are many such. What are these foundations doing? Basically, they help the company or an individual to launch the project with defined format which are successful in the industry. But what is the difference here? It is stage agnostic. It can be either it's a stable stage, or it could be at an early stage, or it can be even later on. Whenever somebody is interested that I need an administrator, I need some expertise in that domain, in industry, in marketing, who can help me to grow, I can approach to this foundation. Then the rules will be defined by this foundation actually. Decisions will be made by foundation. As you can see in the representative image, it's more hierarchical. They have board of directors, technical advisory committees, technical steering committees. They have something called project leader committees as well, and so on. So once you enter into foundation back mode, then you have to discuss with foundation as and when you want to make major changes to the project. So this governance model is very important because it actually helps the industry to know how are you going to make decisions, whether you will listen to the feedback and VOCs that are coming to you. So once you have a right foundation, a right governance model in the place, then you are good to go with the next step. So here we basically are at a stage where our documentation, our bylaws, our rules, and many such things are ready. Now we move to the next stage, which is more technical. It's about the source code. We call it repository. Repository, when you select, it needs to be scalable. You can pick whichever you want. You can have a GitLab, you can have GitHub or Gerrit, or whichever you prefer to use it, but make sure it is scalable. It should not stop you in between when your project is at a very exponential scale. The growth is very nice. So what are essentials of this? What are sections that are actually necessary in this repository? Well, there can be many more. I am bringing out those sections which, if anything is missed, maybe people will be even afraid to join your project. Let's start one by one. First one is about the project. What exactly this should contain? It should contain the purpose. Your charter comes here actually, but here you can have little bit more details. For example, if I go back to the example of lightweight IoT device open source, I might say that this project can cater the devices up to 2 megabytes of RAM and maybe 100 MB of ROM. That kind of little details can come in this, because now you have entered the stage where the little bit of technical information can come out, because here most likely the maximum visitors would be developers. Now once you have that purpose very clearly defined, what's next? You need to give the steps of how to get started, how to compile the code. If it's an embedded software, how do I flash it? How do I run the first demo application? what are the dependencies or dependent libraries to be installed in my system. What happens in this stage is if you make some wrong assumptions and if the project is actually not working in some other PC, they might start discussing with you. But let's say that that problem is getting in iterations and iterations. They will give up on this project. They will start searching for some other project in the same space. So this get started has to be very clear with pictures, with steps, not too much of text, but also balancing between text and images carefully defined. Every single thing can be defined here, and actually it should be defined here. Once you have this in place, your vision has to come here. That roadmap that we spoke about in the first slide during the why and what presentation, that should come here. What are you exactly expecting? Let's say that today I am targeting 2 megabytes of RAM and 50 or 100 megabytes of 120 megabytes of ROM. Down the line, I want to reduce it further. I want to go more lighter. That's my vision. But when? 2 years, 3 years. So you can put few things. You need not put everything here, but at least some information has to come out very well. Rules, contributors, commitorships, maintenance. You have to define these rules carefully. Who is doing what? The names of the existing role owners has to be given so that industry knows who is performing what. You need to provide the email IDs and the way to communicate. Else, people might face a problem and they might not be even able to communicate it. So once you have this stage clear, the next comes contribution guidelines. CLs, contribution agreements basically. So if somebody is interested to contribute to your project, what is necessary? What are the steps the person has to follow before the first code comes in the existence in that repository? How to contribute? Should I start with CLA? Should I send an email to someone with my information? If I'm an individual, how should I do? If I'm a company who want to contribute, what are the policies? Do I have to pay something? Is there any membership fee? That has to come in. Bug tracking guidelines. What if I find a bug in a system? I can fix it, but where should I log it? Or is there a mechanism where I can discuss in a call or in a meeting and I can fix it? Quality requirements. I can give an example in ORAN Alliance Software Committee. There are situations where basically you have to have a unit test which is like covering 70% of your total code, or it can be even more. But if it is less, your code might not be accepted. What are the coding standards to be followed? So coming to the basic requirement, it's quality requirement. So once you have this in place, people will know that what is the highest standard of quality this project can actually have. The projects which do not define this, well, they are still liked because companies take it, they refactor it, they use it. But the projects which define this carefully, they have a potential that they can grow much bigger and with the trust in the community. Moving to the next step, the license. We have already seen the different type of licenses. So in this step, you have to define the license. You have to put a dedicated file of license there which talks about what exactly you expect in this project when it comes to legal terminologies. Once this is there, communication, Slack channels, emails, mailing list, all that in situation, if you cannot communicate properly, there are chances that you will have a project which starts well, but in between it will stop because there is nobody who is responding, or people don't know how to send issues, how to discuss the issues. Last but not least in this section is code of conduct. I generally call the word toxic environment. There are situations where there could be conflict of interest. There are situations where somebody might violate the rule of the project, could be a legal issue. How to handle it? What are the steps taken if something goes wrong? That code of conduct has to be defined here carefully. There should be a dedicated role and a person who should be contacted or communicated if such situation happens. So this is the minimum essentials of the repository for an open source project. Moving to the next slide, assuming that now you have a good code in place with all the essentials, this is the step when we are ready to fly high. So in the previous slide, we were at the stage where we are ready to take off. We have uplifted our front tip of our aircraft and okay, fine. Now we are in the air. Now what happens next to make sure that there are less turbulences? Even if there is a turbulence, how do we manage it? First and most important thing is we need to have regular communication, meetings and webinars. Most of the projects are very basically in a silent state, or I have seen that they start contributing, but it's in a silo mode. Somebody is contributing, people really don't know why that contribution is even coming. So it's necessary to have regular meetings. I'm not saying weekly or like a bi-weekly every time, but you need to have a regular communication and webinars to educate people, to discuss people, to listen to people, to update them what is happening. If you are working on the foundation-backed governance model, then it is important that you convey the updates of board of directors. You convey the updates of technical advisory committees here. There could be some VOC coming from the industry saying that your software has a bug. This meeting can be used to discuss that point. Once you have that thing available, the next step is workshops. It's very important to have whiteboard exercises. As we all know that without having whiteboard exercises, the collective intelligence doesn't really work well. But nowadays, because of COVID-19, I understand that the online workshops are happening and that is actually helping. But there are certain limitations there as well. Like today, we are having a virtual workshop, it's fine. But we do need some sort of whiteboard exercise to discuss about bugs, about the futures, about the roadmaps, about the vision, and then announce it to the community saying that this is what we're thinking to do. So this is about the workshop. Now, last but not least, most important is the visibility of your project, conference and exhibitions. One has to join, for example, there is like Node Foundation event every year in Bay Area. If your project is around that space, take a booth, go and present, have a poster presentation. That helps you to build the ecosystem, that helps you to bring in the developers, more companies to join your project. That can also help you to add different type of requirement which you might have not even thought about it. For example, today I am into home IoT and I am entering into edge space. What kind of requirements I need? I may not be expert, but I might need somebody else who's an expert. By having such conference and exhibitions, it helps to bring in such players in the ecosystem and in your project. So with this, we are flying high, and I hope it was a good learning for everyone. Thank you very much.
Thank you, Dwarka. Would you like to lead to the next session, Dwarka?
Yeah, so just give me a second.
There is a question in the chat window, Subhash, if we can take it.
Yeah, if there is only one question, then why don't you quickly take that, Dwarka?
Sure, why not? Please tell them.
I think the question is, which is the most widely used license for open source hardware? And if hardware is under Creative Commons public licenses, can we use it for commercial purposes?
Yeah, first of all, thank you for the question. Regardless of its hardware or software, you can still have the MIT or Apache license, because these are the open source licenses that are mostly applicable. And coming on the Creative Commons license, yes, it is possible that you can use it and commercialize it, but in some creative commercial license, there are version numbers. And depending on the version number, there are caveats given that they have captured the data from some other open source, so they might not take the responsibility of it if something goes wrong. So you might have to approach the author of that project and actually figure it out who is the next level where the person can contact. That's the answer to the question.
Thank you, Dwarka. We probably should go to the next session now.
Yeah, so let me introduce the next speaker. I would like to invite Mr. Kasif Khan from Nokia. He is going to take us through ORAN and way forward, as Dr. Alok has mentioned about it, and Dr. Subhash also mentioned, ORAN is one of the pioneer project in the current industry in the communication space. So here I would like to hand over the control to Mr. Khasif Khan.
Yeah, thank you, Dwarka. Hi, this is Kashif, and I'm with Nokia and part of 5G portfolio evolution product management team placed out in Bangalore. I would share my presentation. Give me a moment, please. The screen has frozen. It will take a moment. Could you hear me?
Yes.
Yeah, Kashif, we can hear you.
Yeah. But I don't see this sharing working for me. Do I have permissions to share? Do you see my screen?
Yeah, it is visible.
Okay. So the topic on which I'll be talking is ORAN and way forward. So I've structured it in three parts. Firstly, ORAN introduction, and then what kind of momentum ORAN is getting in the industry, and then what are the opportunities and challenges for ORAN. Okay, to start with ORAN introduction. So I think most of you know about ORAN. It was launched in 2018, and it is a forum which was formed by merging XRAN and CRAN Alliance. And in 2020, we got this collaboration between ORAN and TIP in February. And right now there are 180 plus contributors in ORAN, and there are 9 key working groups. And if you see, all the tier 1 operators are part of, telecom operators are part of this ORAN, and they are leading different work groups. And in this forum, we don't have any vendor leading the group. Vendors are co-chairs. It is all the tier 1 customers mostly who are the chairs of different work groups. So this ORAN alliance have certain objectives. So first of all, it wants to open different RAN interfaces to allow multi-vendor combinations. I'll come to different interfaces which are being opened up through this ORAN alliance. And what it has done is it has increased the overall ecosystem. So the time to market has reduced. There is a faster time to market to deploy any certain service in telecom due to ORAN. And of course, innovation has also to have the possibility of this multi-vendor combination and to have different XApps through these open APIs. So overall ecosystem is increasing and bringing the value in the RAN. RAN programmability, I'll come to it. I have one slide for this RAN programmability part, but in short, it is a kind of adding value in the network where you can optimize the RAN performance through this open interface and APIs brought in by ORAN. So if you see, ORAN has 9 working groups. And work group 1 brings in overall architecture and use cases. Work group 2 is for a non-real-time RIC and A1. And I have marked work group 3 and work group 4. Work group 3 is where we have near real-time RIC. And E2 interfaces are being defined here in work group 3. which is co-chaired by Nokia. And this open front hall, the interface between DU and RU, this is defined in this work group 4, which is co-chaired by Nokia. And as work group 5, we have these F1, W1, E1, X2, and XN interfaces. Work group 6 is for cloudification and orchestration. Work group 7, where we are discussing white box hardware. And the stack design, reference design is being discussed in work group 8. And work group 9 is about OpenAccess transport. So this is how ORAN Alliance has 9 work groups, and Nokia is co-chairing 2 work groups. And as I mentioned, no vendor is chairing it. It is mostly chaired by operators, CSPs in ORAN Alliance. Okay, coming on to the architecture part of ORAN. If you see, it is introducing new interfaces, A1 and E2. A1 interface, as I said, is between SMO or ONAP and a near real-time RAN intelligent controller, RIC. And then E2 is between GNode B and RIC. So RIC is where we are having network optimization applications running on top of this platform. And then third interface, which is being defined by ORAN, is open front hall. That is between DU and RU. So, and what we see, the major interest among the customers is across these interfaces, open front hall and around E2, and of course A1 also. And this forum, as you know, is evolving, and specifications are also evolving. Not all interfaces are complete in terms of maturity of specifications. If you see F1, there are still specifications, kind of M-plane specs are still missing. W1, it is not complete. E1 is basically between CUU plane and the CUC plane. The requirement here is to bring the CUU plane closer to the cell site. So for real-time applications where you want to serve lower latency use cases, so that is where E1 is coming into existence, and the specifications are not yet completed. These interfaces, which I have tried to keep in the box, they are relatively mature. X2, XN, although in XN, and the profiles are based on release 15. Front hall, open front hall, which we call it, this is 7.2x split, which has been adopted by ORAN Alliance. So this specifications are complete, and profiles are defined, although it's a bit complicated interface. E2 interface, which is there in work group 3, specs are available for the interface, although there is a possibility to run third-party APIs also on top of this platform RIC. So there is an exercise going on in ORAN to define the APIs of for those third-party XApps. So that work is going on, although the interface between GNode B and eNode B and RIC is defined. So E2 interface is defined, APIs are being defined in ORAN. Similarly, A1 spec is available, but API framework is under development. O1, the specs are available, and I see that different PM, CM, FM functionalities, these specifications are available in ORAN, and they refer to 3GPP specifications in turn. So I see that lots of development and lots of activity happening around this space. So this is how ORAN interfaces are structured. Okay, what is ORAN? Is it getting momentum, or is it getting attraction? Are these networks being deployed? And what is the future of ORAN? So that part I'll cover in ORAN momentum. So if you see, we are seeing different forecasts. So there are different opinions as such. In the ABI forecast, what we are seeing is by 2024, O-RAN share in telecom network deployments would be around 25%. So, and it is going to grow. You see in the orange bar, it is going to grow and probably exceed end-to-end single vendor deployments, more than single vendor deployments by 2030. But there are other opinions also. Like Del Oro, it is saying by 2024, we would have only 9% share of O-RAN in the RAN market. But whatever the case may be, this share is also not small. So O-RAN, what we see is gaining momentum, and it is getting supported from being supported from different directions. It is being asked by the customers. And if you see the forum, as I mentioned, it is driven by the customers, by the CSPs, and they are taking care of their interests. And they are asking vendors to deploy O-RAN compliant network, O-RAN multi-vendor network. And then another push which we see is coming from governments. There are different funding and tax incentives being offered by different governments. I'll come to each of these sections maybe with a slide later, but just to give you a feel of it. Ecosystem is also supporting O-RAN, and we see different chipset vendors, web scalers. They are coming and providing solutions to work with O-RAN to kind of support O-RAN. Vendors, it is supported by existing vendors, classical vendors, and there are new vendors who are trying to break in through O-RAN. So we see both type of vendors in O-RAN space. If you see, I have just put a couple of references. Dish, which is deploying network in US, a greenfield operator. It has decided to deploy O-RAN network, multi-vendor network in the complete country in the US. Similarly, we have DT, Deutsche Telekom in Germany. They are planning to deploy O-RAN network, and they have come up with the concept of O-RAN Town, where they will test multi-vendor deployments of O-RAN. Similarly, Telus is also asking vendors to support O-RAN. And we see Rakuten, which was a kind of a first CSP to start a countrywide network with O-RAN. And now there's some joint venture between Rakuten and Telefonica, where Rakuten is expected to share its experience of O-RAN with Telefonica. So we see these customer expectations of O-RAN is coming in this in the telecom market. So it is supported by customers, the customer demands basically. Governments. If you see, I have just put a couple of examples. Different governments are supporting in different ways this O-RAN deployment. Germany, for example, has allocated Corona Recovery Fund, where they have earmarked around 2 billion euros for new technologies, and O-RAN is included there. In Japan, tax incentives for the operators, including a requirement for openness to international standards, security and supply sustainability. So if the operators are deploying open O-RAN compliant networks, they would get tax incentives, and we see that different operators, be it KDDI, Docomo, SoftBank, they're trying to go into O-RAN deployments. In the US, they have passed a bill to support domestic 5G equipment market and Open RAN with around 750 million euro, and I think it's dollars, $750 million funding. So that kind of initiative is there in different governments. So this is also giving a push to ORAN. Okay, from the vendors, I can talk about Nokia. So Nokia is coming up with ORAN compliant network. So, and that is recognized by the market also. If you see John Madden, he is the principal analyst at Mobile Experts. He is giving a statement that Nokia is the only major vendor that is fully committed to actively deploying ORAN interfaces, ensuring its 5G solutions support the future open ecosystem that operators are looking for. So this kind of testimony is going into the market on the products which we are coming up with. And similarly, and the light reading analyst is also giving in his article that Nokia is the first big kit vendor to unveil ORAN suite. So yes, Nokia is kind of leading in this area and coming up with ORAN portfolio for RAN radio access network. So ORAN is being supported by the vendors too. Okay, Nokia has also joined Open RAN Policy Coalition, and it is a group of organizations which is formed to promote policies that push the adoption of multi-vendor open radio access network. So, and this is kind of reinforcement of Nokia's commitment for the deployment of future secure mobile radio access networks. And the job of Open RAN Policy Coalition is mostly engaging with the governments, guiding them on radio access on these telecom networks. So through this, Nokia is also working with different governments, and there are many other vendors also participating in this exercise. Okay, from the ecosystem side, if you see, ecosystem has also started supporting ORAN deployments. We see that Qualcomm has introduced a 5G infrastructure platform to drive cellular ecosystem transition from vRAN and interoperable networks. So interoperable networks are mostly ORAN networks. And very recently, we saw that Marvell is also coming up with its merchant ORAN platform, they're calling it, so in which they are supporting ORAN deployments. Similarly, we see that web scalers, they're also supporting this Open RAN and vRAN to enter in the operator networks. So we are seeing Microsoft Azure and ONF 5G SDN project. So this kind of announcements are being seen to support ORAN deployments. So ORAN, if you see, it is getting support from different directions, from customers, from vendors, from governments, from ecosystem. So that is how the push is coming to support the ORAN deployments. Okay. Moving ahead in terms of challenges and opportunities. Yes, ORAN is offering different opportunities and there are different drivers for ORAN, but there are challenges too. It's not a plug and play. So if you see open interfaces, they are providing flexibility in supplier selection for RF and baseband. This ORAN front haul, open front haul, is giving telecom operators an opportunity to select DU from one vendor and RU from another vendor. They can select XApps from the same vendor who has deployed RIC, and XApps can come from third party also. So the vendor lock-in has kind of reduced with ORAN. And there is a decoupling in hardware and software, the second level of decoupling where you can buy hardware, and that is majorly in cloud-based deployments, where you can take hardware from one vendor and run the network function we call VNF, a virtualized network function. They can run from different, they can be sourced from different vendor. So there's a decoupling in the hardware and software level also. And with vRAN, when we are talking of decoupling, it is offering network slicing opportunities where we can offer dedicated resources to different use case requirements. So that is also there in vRAN architecture. RAN programmability is also one of the major advantages which we say that, okay, that will be achieved through this E2A1 interface where we have XApps sitting here, and they can optimize the RAN performance in a granular way, which was happening earlier at maybe at this level, at NetAct level. At SON kind of performance, you can achieve very closer to the site and at a much granular level, at the cell level, at the user group level. So that kind of RAN programmability be achieved with ORAN, RIC and XApps. And there's lots of automation we can achieve through O1 interface, which has started coming on these SMOs running in network deployments. So these are key drivers, advantages which are attracting ORAN, which are attracting customers towards ORAN. But yes, it doesn't come for free, of course. So what we have done here, we have disaggregated the RAN. And somebody has to integrate the RAN, aggregate the RAN. So reintegration or aggregation of the RAN, let's say you have bought, some CSP has taken RU from one vendor, DU from another vendor. So then somebody has to play a role of aggregator here, integrator here, to make sure this interoperability, performance, feature and roadmap alignment, it's not an easy task. Life cycle management. So there is a new role of end-to-end integrator here in ORAN, which either CSP discharges or finds out some party to do this. Because if you see, ORAN has defined profiles. We call it IoT profiles. So those profiles would be selected on this interface. But then that has to be adopted for all the features which a customer is looking for. And that end-to-end functioning of those features needs to be guaranteed. And not only functioning, but it should be up to the acceptable performance level what is required by the customer. And then there should be an upgrade alignment, that when this RU is going to get upgraded, bringing in new features, that should also be supported by the DU. So this kind of reintegration responsibility has come in additionally in the ORAN deployments. And now these ORAN deployments have to coexist with legacy networks, which may not support ORAN and which don't support ORAN, and even legacy 5G, which is not ORAN compliant. And another challenge is adoption of ORAN is not consistent across all major vendors. We see that it is not being supported by all the vendors. Few are supporting it, few are not. So that needs to be taken care of. And then when we are splitting it up, that requires to be supported by the transport network also. So this kind of separation, what we are doing, splitting up CU and DU, bringing maybe DU closer to the site, bringing baseband closer to the far edge cell site, that requires to be supported by transport and fiber deployments also. So that is also one of the challenges. Okay. Now, in terms of opportunities, what we have seen is this is Open Front Hall, which is one of the key interest areas in operators. Most of the operators are interested in this aspect of ORAN, Open Front Hall, where they intend to take RU from one vendor and take baseband DU from the other vendor. And to ensure interoperability, ORAN has adopted a certain split. We call it ORAN eCPRI 7.2 access split. And it is in such a way that if you see the stack is also shown here, beamforming and RF goes to RU and rest everything goes to DU. up to F1 interface. So that is where the challenge is to ensure that these IoT profiles, which I mentioned, these IoT profiles are defined at this interface, eCPRI Open Front Hall interface, and there are plenty of IoT profiles. I can say more than 100 profiles. There's a Cat A, Cat B, FR1, FR2, TDD, FDD, beamforming, digital beamforming, analog beamforming, no beamforming. So there are different varieties of IoT profile which are there. Now, these two boxes, the DU and RU, needs to get married through these profiles. Both the sides need to support this profile for interoperability, function, feature compatibility, and performance achievement. So that is an opportunity, but a challenge as well, where ORAN has to ensure that this TCO advantage does not impact any functional or performance criteria or benchmark set up by the customer. So that was one area. And the second area, as I mentioned, is near real-time RIC, RAN Intelligent Controller. There are certain use cases which were looking for latency up to maybe more than a second. So they are deployed at this level, and maybe our centralized SON kind of products were serving it well. But then a few use cases have come up which require latency support between 10 to 100 milliseconds. And they want to be deployed closer to the RAN. And that is the space being filled by this near real-time RIC platform, RAN Intelligent Controller. What is it is doing, if you see, it is connected to G-Node B to the RAN through E2 interface. And it is connected with through A1 interface from SMO or NMS, and O1 interface from the G-Node B side or from the SMO side. So what it is getting different performance measurements from the RAN, different reports. So E2 interface defines different services, they call. So there are report, policy, insert, control, different services are defined here. So these XApps, these are algorithms running on top of RIC. They subscribe to different services of E2. Let us say report and policy. So they will take certain reports of RAN from the G-Node B. Let's say in case of 5G, they are getting different performance management counters. And then they are making use of it and then recommending certain parameters to the RAN to optimize the performance. So that is how you can optimize the performance at a more granular level, at a user group level, at a cell site level, which was not possible earlier when we were sitting here. So this is a unique opportunity offered by ORAN, where it defines this interface E2, A1, and O1, and RIC. And as I mentioned earlier, the XApp APIs are also being specified, and hopefully in next iteration we would get a standard API. So anybody can bring their API. Let us say Nokia has deployed this RAN here. Some non-Nokia player can also bring in their XApp, and that XApp could give you, let's say, some traffic load balancing XApp, and they can deploy that traffic load balancing XApp, taking the information from RAN and providing a recommendation parameters back to the RAN, which optimizes its performance. So there are different use cases there in ORAN also in terms of network intelligence, like policy enforcement, handover optimization, and resource assurance. You have radio link management, advanced SON, resource control use cases where we have load balancing, slicing policy. So this is a very unique opportunity provided by ORAN forum to further optimize the performance of RAN, which is a unique kind of opportunity given by ORAN. So this was another area. So what we have seen, the keen interest in the customers is mostly coming in open front hall, in E2 and RIC areas. So these are probably the key areas where operators are showing interest. So this Open RAN multi-vendor deployments which are being sought or kind of asked by the customers, they would become successful. They offer good opportunities, but they offer certain challenges also. So this decision should be business driven. So customer must always keep in mind the additional cost of multi-vendor deployment, maturity of technology and interface, and the radio configuration. So there should be somebody to take care of end-to-end role of integrator, and extra cost and complexity should be factored in. And there's no plug and play here. So it's the profiles which are defined in ORAN clients, and the two sides of the vendors need to agree and commit to that profile, deliver the features, and ensure the performance of the network equipment which is acceptable to the customer. It is a successful case provided there is an organization for success. There should be a clear responsibility matrix for all parties involved. As I said, multi-vendor integration should be agreed. And there should be a commitment and a proper strategy in place in terms of content and timing. So, as you see, it was an independent case for a vendor to bring in the new release, but that cannot happen anymore in case of ORAN. There has to be an alignment between the vendors to bring in the new release and the content of that release and the timing of that release. So it should be agreed between the involving vendors of that network. And automation should also be part of it. So that would kind of help reducing the deployment times. And it should be, there should be a commitment of long term. So ORAN is not something I think you can go with short term commitments with fragmentation and subscale vendor landscapes. So operator should have aligned openness request towards all vendors to ensure fair competition, and then there should be a long-term commitment from the vendors to supply the ORAN entities in the customer network. So there are opportunities in ORAN in terms of TCO and in terms of innovation, in terms of time to market, but there are challenges also in terms of end-to-end integration, commitment, and there should be a proper organization for the deployment. So these are a few challenges also there in ORAN. So these are the few things which I wanted to share in terms of ORAN, about its introduction and what kind of momentum ORAN is getting in the market, and what are the challenges and opportunities. So, which I tried to share with you. Thank you for inviting me. Thank you once again.
Thank you for.
There are any questions? I can take it up, or I can respond later also.
Yeah, thanks Kashif. That was a wonderful session. So, Anindya, if there is one question that you would like to pose to Kashif, we can do it now, and the rest we can take at the end of the session.
Yeah, I see one question from Giri Shubra. Well, there are a couple of those. I think Subodh has already answered. I think the question is about, I see similar terminology used, Open RAN, ORAN, O-RAN. I mean, is there a difference?
Yes. Be careful. Every dash and space matters here. Yes. Whatever I had shared, it should be in that way only, O-RAN. So that is Open RAN. Open RAN is also a project within TIP. So that's not what I was referring to, and I refer only when we say Open RAN, it is ORAN compliant, ORAN Alliance compliant.
Thank you. Thank you.
Yeah, I guess with that we can move to the next session. The next session is on ORAN intelligence framework by Avinash Bhatt. So Avinash, over to you.
Thank you, Subhash. I hope I'm audible.
Yes, you
Yeah,
are.
I can hear you.
Good morning, everyone. I hope all of you are doing well and keeping safe. So my name is Avinash. I am a product manager at Samsung and also drive the ORAN related initiatives within Samsung R&D Bangalore. So today I'm going to talk about ORAN intelligence framework. I'll just share my slides. Just give me a minute. I hope my screen is visible.
It's coming up, I guess. It is not visible yet.
Okay, yeah, just let me know when you can see it.
Maybe you have to try one more time. There is,
Okay.
it's not indicating that it is initiated.
I see. Okay, let me just try again.
Yeah.
Okay. I hope the screen is visible now.
No, Avinash, it is not.
Okay. Okay. It seems to be saying it's sharing. So I thought you'll.
Is anybody else able to see? I do not see it on my screen.
No, I don't see it.
Okay, let me just stop my video. Let's see if I can present again. So I've shared it now. I don't know if it's visible.
No, Avinash, it is not showing up.
Okay, so probably maybe I may share the slides with Dwarka, and if anybody can help me project the slides, maybe.
Yeah, that
'Cause I
would be
don't-
great. If
Yeah, I think
that would
wasting
be
time.
fantastic. Yep.
Yeah,
Thank you.
sure.
Yeah,
Please,
sure.
sir.
I'll just send it to you right away.
Please send. I think, Dr. Subhash, meanwhile, I think we can move to next speaker until I get the slides from Avinash.
All right. That is an option. Yeah, so maybe,
I think we can do that. That's better, yeah.
Subodh, are you okay to go next then?
Subodh is in mute. Vinay, would you like to take next?
Yes, sure.
Dwarka, I can get started in the interest of...
Yeah. So you can take over the control. Meanwhile, whenever Avinash sends me slide, we'll put him next.
Yeah, thanks, Vinod, for stepping in.
Sounds good.
Thank you.
I mean, in the interest of time, it's always good to put it out there.
Yeah.
Okay. If you're good, I can get started in terms of sharing my presentation.
Yes, we can see.
Excellent. Thanks. So the way I structured this whole presentation is, in terms of the evolution that we see, network function virtualization to cloud native functions, and how OpenShift and Kubernetes, what is the role of the cloud native emphasis, right? The platform innovation that not just brings the deployment aspects on a virtualized environment, but also on a bare metal. And we will also look at the operator framework, which is largely how do I, kind of bring in the entire knowledge of the maintenance aspects of an application knowledge into an operator that truly drives the cloud native functions. Of course, we've got deployments on bare metal, like I said. And then that leads us into, from a Kubernetes operator framework to the actual network perspective, right? The Kubernetes native interfaces that are available, from a network point of view. Then we will touch upon the service-based architecture, the RAN, and eventually we'll also touch on the edge. And also to kind of summarize this, what is, the most important aspect for us is to see what that is happening in the emerging workloads, right? How edge is really making wave to, the machine learning, the AI, and the IoT workloads, including the latest technologies and open source availabilities in terms of how do I build a serverless function, that the end users can then tap into. And of course, a quick summary at the last. So that's how I've kind of put this whole presentation together. So it's easy for all of us to kind of connect those dots and understand how, open source, Kubernetes and OpenShift kind of platform innovations are helping telcos scale and adopt and accelerate the entire 5G journey. Now, on that note, we all understand that 5G is here, and we've seen a tremendous evolution right from an all IP packet, the carrier grade Linux to moving into network function virtualization, and how do we then achieve what we call disaggregated. And I know, Suhas mentioned at the beginning of the open remarks, it's all disaggregated, distributed networks now. How do we bring in, some kind of a management, some kind of an application awareness from a network and network performance perspective is what is, kind of bringing in the distributed computing node architecture, where I could then achieve the workloads, the emerging workloads like the AI, ML, IoT workloads on an edge kind of a setup. And that edge could be not just from an industrial manufacturing or enterprise private network perspective, but also on the telco edge, how the communication sector, the ICT sector, how the telecom as an industry can then, be a part of the entire revolution that is happening from an edge computing perspective. The efficiencies and the whole total cost of ownership savings that a lot of enterprises are looking forward to. That's what led to the opening of the multi-access edge computing. And where we are now is, of course, like Mr. Giri's question, there are too many Open RAN initiatives, but the true Open RAN is all possible when you split the user plane functions and see how we could have interoperability between a different RU vendor, a different DU vendor for that matter, and that's all deriving through the cloud native function. So if you see at the large, from a platform innovation perspective, it's all towards a cloud native driven network function. So that's at the large what 5G would bring to the table, which is, of course, in terms of the bandwidth, in terms of the low latency applications like the augmented reality, the virtual reality, the mixed reality workloads that we see, as worker productivity also improves in an industrial setup. So that's 5G, literally, in terms of what has been the evolution underneath bringing in this new age 5G era workloads. Having said that, we all have witnessed 2020 being an accelerator for digital transformation as such because of the COVID-19 situation. And from an industry overview perspective, what we see is that nearly all major telcos will have launched 2021. And if you see this week's announcements at the India Mobile Congress, Reliance Jio has announced to be launching their 5G services, and of course Airtel have also kind of emphasized on their timelines that they would be achieving the 5G trials and rollouts and things like that. Now, having said that, what is the Red Hat's positioning here? What do we do as at Red Hat? Is as you all are aware, we're the world's largest open source driven, community driven approach enterprise company, where we work on these upstream projects, open source projects. We harden it and make that available for enterprises, and we provide subscription. When I say subscription, we provide support so the organizations can build business features on top of it, and we continue to take care of everything underneath the hood, from the infrastructure, the platform, the operational requirements, and so on and so forth. And what that means is faster time to market, your ability to launch the 5G window is shortened. The ability also to tap into the ecosystem because, we're platform agnostic. The fact that you avoid vendor lock-in, you have a larger degree of interoperability. What that means is it's truly flexible, adaptable, and very portable marketplace. Sets you apart from the combination perspective. I know Dwarka at the initially mentioned, the whole need for opening up, if you're adding something to an open source, to make that available for the industry so that they all can benefit out of it. So that's been the principle at Red Hat, and everything that we do is at the central of openness. So that's from an industry perspective, and I would like to touch upon the evolution that we see. I know Suhas definitely Dr. Alok mentioned in terms of what Kubernetes is bringing to the table, and how Red Hat with OpenShift is making that possible at an enterprise scale. Now, in terms of that evolution, we've seen a typical setup, anywhere from 2018 to 19, where you had seen the system of engagement largely being driven by OpenStack, and then the hypervisor, which plays such an important role of bringing in the isolation of the various workloads, which was largely driven from a hypervisor vendor. And then you saw that about 30% of consumption that was largely led by a container world, where Kubernetes, OpenShift played an important role in terms of giving the developer community everything that was required to package, the application intelligence, the ability to be, where you could port that across various technologies, various, the way you deploy and run the underneath platform. All of that was packaged into the system of engagement, and we saw that evolution grow, right? We see, somewhere around the end of 2019 and the beginning of 20, we saw that there is a significant consumption of, the container-driven workload. And that's where there was a side-by-side implementations that we've seen, from some of the telcos and enterprises where, OpenStack, which is again a flagship offering of Red Hat, continued to provide a typical, cloud, telco cloud perspectives. We also saw the Kubernetes taking its own position for the stateless and stateful containerized applications workload. Now, what we also see in the beginning of 20 and the COVID situation, the acceleration that we've seen, and if you've seen this year, we've our announcements on KubeVirt, and we've started on Kubeflow and things like that, which is all open source projects, upstream projects that you all can port and add your value on top of and contribute it back to the community. We've seen a coexistence now. We've seen a tremendous ability to bring in your legacy workload and co-host that along with the container, and that I think is again a very important point. And Kaushik brought up that very, very important point in his presentation, that there are legacy workloads, and how do you kind of bring that ability to manage the legacy as well as the new things that are happening in the Open RAN perspective, right? Because there are different vendors. There are a few vendors who support this initiatives. There are a few vendors who are not supporting that, typical initiatives that we see in the market. And that's where there's a need for us to kind of bring both the type of workloads, be it hypervisor driven, which is a typical virtual machines and virtual network functions, and also the containerized based workload. And that is what is possible with OpenShift. And we see what organizations are moving into is a very standard way of putting together the best practices, which has a proven outcome, a proven methodology, where they start hosting their monolithic application on a virtual machine kind of on-demand platform. At the same time, they initiate a process called strangulation, where then they break that entire monolithic architecture into microservices, and that is possible with OpenShift. So that's the evolution we've kind of seen, and I would like to bring that to your notice so that you know and you have a roadmap for your organization as such. Again, to quickly go back and summarize from a Red Hat perspective, what do we do from a communications industry perspective? We're number one, as you guys are aware of, from a Linux perspective. Red Hat Enterprise Linux has over 65, approximately 65% plus market share. We're the number one in the NFV infrastructure, the virtual infrastructure management interface, from HC's architecture perspective, with our flagship offering called OpenStack. We've also are the number one in the container platform as a services market, with approximately about 45% market share. That's our OpenShift, the flagship offering that we have, and that kind of ties the evolution from an architecture perspective from OpenStack to OpenShift. And we also have various deployment scenarios where we could install OpenShift on OpenStack as well. What that brings to enterprises and telcos is the ability to embark and adopt the cloud native functions, build microservices, service-based architecture, and overall provides that cloud abstraction layer that could truly simplify, from a hybrid cloud perspective. Again, from an open source, Dr. Alok has already emphasized this, the need of preventing, lock-ins and interoperabilities and things like that. That's the prime, emphasis that the enterprises and partners can tap into to grow in this ever-changing environment. So that from Red Hat's perspective as an industry overview, but what is our vision when it comes to helping enterprises in their developer productivity in terms of the ability to build things fast, with all the DevOps cycles that they will have to go through, from an operational efficiency perspective. We're not just talking about the data centers or the public cloud perspective, whether it's any kind of a form factor, such as it on a physical bare metal or a virtual environment. we're talking about all of these efficiencies, all of these productivities, all the way to the edge, and that's Red Hat's vision. That's what Red Hat has been, working towards, investing all our time, efforts, and resources into. Now, how do I kind of summarize all of this, for you guys? Is in terms of the different edge, right from the core to provider edge to an industrial edge. Red Hat OpenShift, which is built on Kubernetes, is the common platform that brings that consistency, brings that openness, and brings the hybrid multi-cloud, value proposition to the customers, which is truly what is required at this point of time. And having said that, if we see the expansion that is happening, like I've already emphasized, the typical remote offices where there's no maintenance as such that is possible, or there's less worker productivity in terms of a real reach that kind of differentiates a central site versus an edge site, and all of that is what we believe is the future, where we see a lot of action that is happening right now, and that truly enables organizations to tap into innovation, which is survival instinct right now, with the ability of new startups and niche players expanding their market share, becomes such an important point for all organizations as such. Now, if I could summarize that from a network perspective, we've seen, right from the monolithic application, it's a black box tied closely to a lot of application specific, specific integrated chips, and all the way to then bringing, the typical x86 kind of an architecture where it is open from a hardware perspective. It's not very affordable, economical, emphasis, not very tied to something which is expensive hardware appliances, right? That moved larger to our network appliances that really gave way to what we call the network function virtualization, making it possible on a typical x86 kind of underlying infrastructure. Now, what that also led to is the innovation of OpenStack and container world, which is typically microservices in containers, and that's where we see that evolution, that transformation, moving from OpenStack and OpenShift perspective, and that's from what we've seen as a technology evolution from a network transformation perspective. That holds good for not just telcos, but all those typical players who are in the space of media, broadcasting, and things like that. Now, if I could bring the industry overview, bring the emerging workloads together into one vision, which is of the most prime importance to all organizations, is how I know I'm getting into an intelligent application scenario where my application is aware of the depth of performance, where the application can demand a slice for itself every time there's a network intensive, data intensive, latency intensive action that I will have to take. So how is that visibility then drives underneath the platform layer, be it from a network perspective or even storage and so on and so forth. But I limit this entire presentation only from a network perspective. So what that means to the enterprise is the fact that irrespective of what type of format, the form factor, or the underlying infrastructure, I have this one vision that drives me to develop on OpenShift and deploy it anywhere, be it physical emphasis from various vendors, virtual emphasis with various vendors, to a private setup, where it harnesses the value of public cloud as well as your own private cloud, which is true hybrid for the large enterprises, and also to the public cloud, right? We've seen a lot of ISVs who born on cloud. We've seen a lot of startups who are kind of growing in the path of the public cloud perspective, where they were born on it and they continue to grow and become unicorns and large enterprises. There's a need for them to kind of adopt that as well, and to a telco edge or a provider edge or an enterprise private network. the ability for the organizations to develop once and deploy it anywhere and operate it is the key, the key focus for from a maintenance, from a total cost of ownership, from the ability to unlock time and investment and resources to work on what business needs and put the business IPs on top of then managing the infrastructure, managing anything underlining the value of the business application that is being offered becomes a key role. So that's how I would summarize the hybrid vision and what Red Hat and the open source tools can bring to each of the customers. Now, having said that, I would now interestingly move towards the bare metal deployment. And before we head to the bare metal deployment, let's look at what are Kubernetes operators. Now, operators are what we call the day two automation emphasis from a lifecycle management, in terms of how do I leverage, automated tasks, which are literally something that could be very repetitive and could be automated, right? And that is where things like installation, how do I provision towards a standard operating environment in terms of patching, in terms of configuration, in terms of over-the-air upgrades, in terms of taking care of the support aspects of everything that has to do from maintaining that particular application, which has the visibility into everything underneath the infrastructure perspective. So the whole application lifecycle in terms of storage, in terms of backup, if there's a high availability, what is my business continuity, what is my redundant link that I'll have to figure out in terms of recovering from that failure. And not just that, we also see, like I mentioned at the beginning of the presentation, there is a need for us to continuously look at insights, right? So how do I really package, the log aggregation, the log processing, certain metrics that I can monitor, certain alerts that I can notify, from a workload analysis perspective. How do I combine that into my application intelligence? Now, when I have all of this, I have the installation, I have the upgrade, the entire life cycle of the application, and also the health of the application. How do I really put it on an autopilot mode? How do I scale both horizontally, vertically? How do I self-heal in terms of identifying the anomalies, anything that's abnormal in terms of detection, and then tuning myself and really moving towards a self-healing perspective. So how do we do that is, the basic installation is supported by Helm charts, and anything that you'll have to do in terms of packaging, provisioning from an application lifecycle, maintenance perspective is where Ansible, that's another open source tool. Red Hat offers subscriptions for there, and everything that you'll have to build in from an operator perspective that you could then attach to another operators that are available, from Prometheus, from a monitoring perspective, and so on and so forth, is where you would use the Golang. And of course, all of this is tied into the operator SDK that any organization can jump in. Now that we've understood operator, and if I can define that operator in simple words, is how do I really automate the installation, the knowledge of operations of that application into something called a software manager. So that's exactly what operator is in a very simple definition. Now, how do I go about doing that? That's very important. So if you understand OpenShift and Kubernetes, everything in the Kubernetes world is what we call CRD, the custom resource definition. So everything that any object that you define goes through the CRD principles, and it has a controller that eventually controls, what that behavior and action has to be for the defined CRD. So CRD is an API extension that kind of interacts and communicates with the controller, and controller actually takes care of the actions in terms of, the lifecycle management. So both put together is what is the Kubernetes operator, and what that brings to an organization is the ability to define your own custom resource, add the controller on top of it to apply actions, and then make that deployed and kind of packaged and deployed towards a cluster where the application is intelligent application. That's where we're all heading. From a workload perspective. So if I could summarize that, I have this operator SDK. I, as a developer, have scaffolded my logic into it, and I've defined my custom resource definitions in terms of objects. Now, if I could give you an example, just to make sure it's easy for everyone to understand, Ansible as an operator that you could use from your application state perspective, where you could define those modules and provision, let's say, a patch. If there's a critical patch that's released, how do I automate it and get it installed onto my application so that any compatibility issues, anything that has to be taken care of is all available for my application, and my application is enabled to truly bring in anything that I can define like a playbook within Ansible operator. So that's how it ties together. You have your custom resource defined respective to your application states, various states. And then you drive the action through file mapping with the Ansible operator as well. So that's an example. So now that I know what is an operator, how do I build about it? Now, how do I really ship it, right? And if you want your customers to make the most out of it, you need to have an ability to ship those operators. Now, what we have is within OpenShift comes with its own registry, and we also have a registry, for your advanced enterprise requirements, where you could then package it, add all the metadata that is required in terms of everything that Dwarka had mentioned from a GPU perspective. What is the support aspect, what is the license aspect, what is the version of this operator. All of that goes into the metadata and then gets packaged and posted onto an image repository. And this image repository is exposed as a catalog to various organizations who could literally use that, deploy it, and run it right away, without the need of having to go through the actual physical setup. And that's how the end-to-end automation brings, from an operator perspective, brings and ties all of that application knowledge into a automated software manager, like I said. So that's what operators brings to the table. Now that we've understood what operators are, how do we really tie this up to the evolution that we see from a 5G perspective, right? That's where the NFV architecture is giving way to adopting the Kubernetes operator framework, where we see the ability to host the OpenShift in Kubernetes on a bare metal and do away with the entire cost layer of a typical virtualization operator that is required. And what that means is I have now the ability to adopt cloud native network functions. It could be any of your functions that you have, right, from session management to any kind of data or authentication management, and several other functions that we get to see. Now, what OpenShift also does, and this is the very important point that I want to bring to the table, is the fact that there are other adjacencies that we see in terms of integration, in terms of API management. All of this gets tied into OpenShift, which means that you have a true cloud, container operating, orchestrating platform, which is very important from an organization perspective, so that you continue to add business requirements, most importantly, than anything else. That kind of sets the whole tone for a true adoption, for an organization. Now that's how we see the layer that moves from the changes that are happening and all being powered by open source tools, largely. That kind of brings this whole aspect to it. Now, after having said that, like I said, let's see how Kubernetes and OpenShift are driving the service-based architecture from a network perspective. That again, there's every time we've seen organizations, break the monolithic, move towards a microservices-based architecture, we see the challenges in terms of the observability, right? What is the connection between different services? When I'm running hundreds of services, how are these services interconnected? What is the true service mesh that we get to see there? Because anything and they're all asynchronous in terms of executing their own actions, and therefore that it becomes extremely important for us to, have that ability to know, how my traffic is moving. The ability to kind of isolate where is the service that is getting impacted, and therefore my entire service chaining is getting impacted, right? So that's where, again, Istio, another open source emphasis, comes into picture. Gives you that ability to, package a network proxy as a sidecar to your application, and then that gives you that visibility and observability factor, so that and understand how the different services come together. Now, the same thing, if I could put that entire components from an open source perspective, is the usage of operator framework. We went through what operator is, how operator framework can be used. Now, for me ability to package, let's say, a GPU, ability to do what we call a CPU pinning, using the DPDKs and the FPGAs, or adopting the serverless. Knative is another open source project. I have that at a later slide. Is all that is possible at various layers. And Ansible, another operator that I said, kind of brings all of this together, where you could then do the automation at the core level or at the edge level, kind of tying this entire service-based architecture. And to kind of bring that emphasis on the AI kind of need right now, right? From an emerging workload perspective, we see that is also possible from the edge layer, where you could then tap into the metrics that we discussed a while ago. Now, that's how open source tools are, truly driving the service-based architecture. See the AT&T driven Acronis Edge Stack project. You would see how data can also be driven out of the edge emphasis, and the workloads that I spoke about, serverless and machine learning. So in some of these open source projects, you see OpenShift being the center, plays such an important role. And what Red Hat is doing there is to bring in a collection of open source and cloud components packaged into what we call a machine learning as a service. That's a platform. Adopt and that platform that can then go out and give you all that insights that could help solve the business problems. And like I said, this business problems are not just about improving your operations, but also going and building new business models and delivering new innovative business emphasis and features and ability to your customers. And that's how we drive that with what we call Open Data Hub. And Open Data Hub, like I said, is where we've brought in all the collections of open source tools to give you a readily available platform that can truly build machine learning as a service for your organizations. And you could visit opendatahub.io, and then you could download, start playing with Jupyter Hubs. It's like notebook as a service, and all of that. And this is built on OpenShift with Kubernetes underneath in the Kubeflow, which is also a very important open source. All of this combined together is what is Open Data Hub. Now, how do I tie this? I mentioned at the beginning that there are not just emerging workloads, but there are also emerging ways for us to deploy and take this to the market, right? And that's where Knative is another open source project that is, putting together the whole eventing and the serving functions, which can give you a true what we call serverless functions, right? Again, that's built on Kubernetes at the heart, where OpenShift has added a lot more adjacencies to Kubernetes to make it enterprise class, true container orchestrated platform. And just to go about to say, we have 45% market share. That kind of emphasizes the fact that how people are adopting open source as a central foundational requirement for their digital transformation initiatives. And Red Hat OpenShift has been the center of that digital transformation initiative across all telcos and BFSI and government sectors that we predominantly see at this point of time. Now, just to quickly summarize, very importantly, understanding what the Red Hat OpenShift and Kubernetes is all about, a quick overview that we saw. How do we truly use the operator framework to drive what site reliability engineering, the provider extensions can truly help very autonomous management in terms of the upgrades, in terms of the installation, in terms of how I deploy, how I package, and bring the ability of health aspects to the application, make the application intelligent in terms of the ability to understand the network performance and so on and so forth. All of that package made that available on a bare metal. And what that means is you're really doing away the entire virtualization layer. That's a huge cost saving for telcos and enterprises all put together. Now, we also looked upon service mesh for the service-based architecture. Again, a very key important emphasis. If you've seen the 3GPP releases, how do I then enable at the edge layer, bring in the UPF, the user plane functions, and ability to then drive slicing and so on and so forth. Then ORAN emphasis, how does KNI truly bring the machine learning as a service through Open Data Hub? It could be at a telco area, it could be at a private, the enterprise private network as well. And then the serverless, how do we truly drive with open source projects like Knative? Now, what also Red Hat does is, it kind of helps you scale and understand and adopt this open source emphasis and open source tools in your core offerings is where we help you get started. We help you certify that your operators, your entire offering as such. That's where it becomes very important. And you could reach out to me. I will be very happy to share all the GitHub repositories for all these projects. So you could also contribute to the open source community, and we will also help you get it certified and things like that. That's pretty much. Back to you, Dwarka, Professor Naveen. If you have any questions, please feel free to let me know.
Thank you, Vinay. It was a wonderful session. Do we have any questions? Actually, we also need to have a time check. We have 2 more speakers to go. So, Subodh and Avinash, you guys may have to a little bit fast track on your slides. So, Subodh, would you like to be the next?
Yeah, I discussed with Subhash. I think if Avinash, if you're ready, you can go, so I can then kind of I'll be the last one. I'm okay either ways, Arinda.
Yeah. Avinash is ready. I have his slides with me.
Okay.
I'm just fine. I think Subodh, if you want to continue also, it's all right. So it's like your call.
All right. All right. I'm okay either way. So how much time do we have exactly, Aninda?
We have actually 21 minutes to go for actual planned time, okay. But I think we'll extend it, don't worry. So let's get going.
All right. All right. So do you want me to go? Avinash, is that okay for you?
Perfectly fine, Subodh. Yeah, please continue.
Okay. All right. Thanks a lot. And, I think part of the fun of being a person on the second segment is you can get segues from everyone. So I was very much plugged into what Vinay, Alok, and everyone was sharing earlier, right? Even Dwarka as well. So let me quickly share this. Should I, do I have the presentation rights, Aninda?
Yeah, you can just click on present now on the right bottom side, a window, and then select the slides.
Yeah. Okay. Yeah, let me know when the slides come up.
Yes, they're appearing.
Perfect. Perfect. So, good noon, everyone. I think we just passed the noon cycle. So, I'm keeping a timer here as well till 1 p.m. So I'll just do a quick breeze through and skip over some part which has been covered in detail by my previous friends. So thanks for that, right? This is the agenda I had in mind. What do we really mean by networking at the speed of DevOps, and why this evolution has happened? I've used 5G and IoT as the two mega trends. So most of my discussion will be around how the future 2025 5G networks by Jio, Rakuten, which is currently the world's biggest one, in terms of virtualized telco DC, in terms of Open RAN. And I can see a lot of questions by Giri and Yerisity as well. So keep them coming. I'm trusting my elite panel members to answer them. So we are just, I'm just going to hinge upon what's really happening. So as you start building these networks, the open source framework, models, protocols, APIs, while they help you, they can also help you in day two, right? So if you kind of look at the architecture principles, day 0, day 1, day 2, right? While you're planning, designing, while you're implementing those deployments, and of course, when you're operating or day 2 operations, as we call them, while it's going on. For example, Reliance Jio 4G is now in day 2. So while we consume Jio every day, they do a lot of inner planning and engineering, right? So open source, whether you call it open source with the whole containers and the microservices model, is really making a lot of dents there. So I have this tall challenge of linking 5G / massive IoT to what's happening in this open source, which is fueled again by softwareization and cloudification, right? I know it sounds like a mouthful, but in simple terms, it just means, the ability to run things where you want in a very programmable way, and obviously not make it so complex that you don't know what's happening, right? The whole purpose of this wave of DevOps is that you had various teams, and so consider all of us on the call here. If we all were employees of one big company, say Rakuten, or I'm just giving an example, and we are all working in silos, not knowing what's happening. So the DevOps culture, the NetOps culture, the AIOps culture is really about providing visibility, providing context, so that applications, people, processes, and the endpoints themselves have a very cohesive interworking amongst it, right? And my fourth section is really about, I took the case study of Rakuten. If time permits, we can go over it, or I can just answer it in the Q&A, either ways, right? So quickly, I think the nicest way is to compare it with a non-IT industry, and what better than urban mobility, or whatever you call as cars, and the present world, or if you are someone who talks to Elon Musk every day, he will actually call it an autonomous vehicle. Right? So we have many evolutions here, but consider the networking also. If you look at the past, from the world of CLI, SNMP, Armon, Syslog, is now slowly adopting this click to fix, or self-fix model, auto-healing kind of thing. And the reason you have the Vodafone ideas, the Bhartis, the Reliance Jios here closer at home, or the AT&T, the Verizon, the T-Mo, and PLDT here, or China Unicom, they all are at different points of this. They have people, they want to deploy, say greenfield 5G in case of say Rakuten, or say a brownfield 5G in terms of Jio going from 4G to 5G. And they have these huge networks, right? So just to lay the context for everyone here, Reliance Jio has around 150,000 cell site routers, right? That is what powers the 4G network. Just in terms of the routers placed at the cell site routers, 150,000. And then if you add the aggregation layer 1, 2, 3, the telco DC, and everything, just the number of routers and switches could go beyond 2.5 lakh. So 250,000 devices just by one provider. You definitely would need some degree of automation, right? And let's blow that apart when you talk about what tools go into it, along with open source. So I'm not going to go into deep of this, but this was covered very well by Dwarka actually, when you embrace the roadmap. But a lot of people look at digitization as just equal to automation. It is not. It is really about saving time, complexity, and making sure it directly links to your revenue also, right? So Jio would embrace an automation solution. Rakuten would go for a self-provisioning solution only if it automates something. Now in this, this whole potpourri of things happening around us, we have bare metal, erstwhile physical, bare metal now merging, and pretty much applying a microservices / continuous model. How do you make them behave? How do you ensure, well-behaved VMs work together, whether you have an IoT connected car solution, whether you're deploying a 4G to 5G network, at the same time hosting wholesale retail or enterprise customers. Service providers are not going to make money just by 4G or 5G data connections. Enterprises are the new hotspot now, really. Look at the huge offices by Wipro, TCS, Infosys. Look at how the convergence of Wi-Fi 6 and 5G is going to happen. So all these challenges come and present to you for automation, right? The one we are probably going to do a very deep dive is the top right one on DevOps and the CI/CD mindset, right? The continuous improvement or the continuous delivery model. And again, same example. Imagine 50 of us are in 50 different teams in a common company, and if we do not talk, how is a company going to look at us and say, please deploy the second release of whatever you're running, this product? We would be independently coding, developing, testing, securing some APIs, but not gravitating towards the big picture. So the CI/CD mindset is a given when you have over 2.5 lakh routers just by one provider. And let's say if you just have to upgrade even half of those, just think, and you cannot do that in a finite world, right? So 99.999% uptime translates to less than 12 minutes of an outage in a year. So you definitely need your IT, networking, development, which itself could include so many people, right? Your software integration testing, your benchmarking, your triaging, your security teams, your server teams, all of them to talk to each other. And that's what, that's what happens when you work on various technology pillars like this. So there is an automation part, there is an orchestration part also, which is pretty much, again, in the software world, driven a lot by SDN controllers. There is a portal part in which everything manifests. Think about like a smartphone app kind of a view of your whole network. And at all points of time, you want to make sure if you're upgrading, say, 20,000 routers or switches, they have downloaded a new image, whether an open source or a proprietary image of a vendor, and they're working as per the new specifications. So that's why this continuous integration / deployment has to be like a life cycle, right? If you imagine the infinite loop, it's a nice way to represent that. And this is like when you spend 3 or 4 days on site at Rakuten or at at Jio or at Vodafone Idea or at Bharti. This is the day in the life. If you are from engineering, these are your priorities, right? This is what you want to do, provision new people. A TCS or a Wipro could go to Jio and say, we want to onboard 7 of our ODCs, right? We want to provide, say, a hybrid cloud connectivity using SD-WANs on your Jio networks. Can you do that in a week, right? AIML here, just to demystify, right? You need all of the decisions in the blue and the green pillars to have the unsupervised and the supervised learning framework. And there's a lot of forecasting. There's a lot of what happens if I roll this image? What will be the effect of this switch or router or this cell site router? So knowing things before they happen. So you have a data plane or a control plane, but the car could be driven or operated by somewhere else on the cloud. The data plane is the tires, the engine, the powertrain going on. So you're decoupling the heart, right, and the brain of the entity. That's what SDN is really all about. I took this one step further just to introduce the open source concepts. This is what goes on in an SDN world. You want to do something, and unfortunately, when you translate that to actions, it just generates 10,000 steps, and you do not know which team owns what. So in simplistic terms, this needs to gravitate on the right to an architecture infra. This is the SDN NFV controller, and my UI UX will look like this, right? So the time has come to break down this huge 7 plus 9 layers in OSI or 7 OSI layers to a simple 3-stack model, which pretty much powers what the 5G architecture shift is all about. So if you look closely at 5G, as I use these two words, but softwareization, the ability to decompose, break down into small logical managed units on the radio side. So the Cloud RAN becomes a very dominant concept, and then the ability to cloudify them also. These are the two ways in which 5G has a major architecture shift. The control user plane separation already existed. 3GPP had done that in release 15. 5G has just accelerated that to the next level. So the tools which really aid you, if you look at all of these, right, in the open source would be, you want things.
Good, sorry to
so basically you want
interrupt
a modeling place, a place where you will model, just like you put a blueprint.
Subodh, sorry for interrupting. Could you please stop and reshare your presentation? Some reason it is not showing up. Thank you.
Oh, okay. Thank you. Subhash, is it okay now? Let me quickly stop here and start again. I think it had a little animation in between. Maybe that's why it went for a toss.
Yeah, please share again.
Let me know if it comes up.
Yeah, it's good again. Thank you.
Are you seeing it now? The animation?
Yeah, it is showing. Thank you.
Okay. Hey, thank you, Subhash. Do you want me to? Yeah. Do you want me to go back one? I don't know if it froze earlier. Are we good with this?
30 seconds or so, I guess it got interrupted.
Okay, no worries. So for anyone in this world, whether you talk massive IoT networks, whether you talk, huge private or hybrid cloud-based networks, the top left is the philosophy, right? This is the way your new teams have to work in a parlance in which they're all tightly integrated to each other. The protocols, the languaging could be, the way you encode could be, XML, JSON, Python, Ruby on Rails. That doesn't matter, right? And you could either go for a proprietary or an open source license. We have Danos, we have P4, various options for tying your hardware to a commercial license. But not the least, this is the evolution we are seeing. I have a network, I need to do something to it. So you want the intent to be declared by the user. And that is pretty much what 5G is also all about. 5G is not about just high speeds or connecting billion objects. 5G is what do you want to do? What does a TCS or a Wipro look at a 5G network, right? Connecting maybe 40 offices, connecting or interoperating their Wi-Fi 6 in the campus to LTE advanced 5G. So this is what the declarative mode is all about. This is how now the model driven, or if for people interested on the IETF side, you can Google up RFC 6020. That's what YANG is about. Yet another next generation. And that is pretty much like a modeling language. So you model, just like your house has a bedroom, a living room, a kitchen, a cabinets, and then you have sub-models. So you classify any vendor router, what number of interfaces, what ports, what virtual interfaces, everything can be modeled. And these are the three layers of it. So netconfig becomes the protocol, and restconfig becomes a consumable API. The biggest example of restconfig is our browser itself. So it performs all the functions. When you have a modeling language like YANG, which is now an approved RFC, and then netconfig, you're fundamentally opening up the way you code a router using any object notification. So it could be JSON, it could be XML coding, anything which is supported by the world or in the open source forum. And then you have a protocol in which you can go and actually change it. So the get, post, patch are pretty much like the MACD operations we call about, right? MACD simply means move, add, change, delete, right? Or CRUD as it's called in software world. And it's pretty much one of the most dominant examples. I can give it to you now, if you look at it very closely. So in all cases, this is where the power of machine learning and high resolution data also now comes in. Talking about lakhs and lakhs of routers churning not just subscriber traffic, enterprise traffic, or billions of objects connected, as I think Vinay covered it when he spoke about massive IoT. So network telemetry, right? The data generated from this, whether it's even generate petabytes of data, that needs some complex event processing. And then you need insights. So which part of the data belongs to a common purpose? Say common traffic lights, traffic light data coming or sourcing in a connected car scenario. And then what is the guided remediation you want to do? What is the final outcome you want to achieve? So this is pretty much some use cases I'm given just from a networking perspective. But irrespective of whom you go in the world, you would typically look at this. They all want to have compliance and security, right? If you build a house, you build it top notch, and then suddenly somebody comes and says, I'm the field inspector, you haven't built the kitchen and the electricity compliant with the state or the federal regulations. So that's a big one. You can read all of them for yourself, but this is how it goes on. I think most of this was also covered by Dr. Alok and Dwarka as well, right, in the roadmap and the opening keynote. But I would say, if you look at Rakuten, right? Again, I'm just using Rakuten because they were pretty much like an e-commerce or Flipkart kind of a company in Japan, and they now have, really, I would say, taken up this challenge and pretty much solved it. Also, when you look at the first fully decomposed SDN network for 5G, greenfield, they interoperate with almost 50 plus vendors. Nokia is part of it. Kashif covered that. And Ericsson is there, RTO is there, Cisco is there, and the whole ecosystem really is about you disaggregate the RAN, right? So you're breaking the RAN from a traditional proprietary way in which it was, it was great just to provide speed, but it was not great as a RAN to embrace connected cars, to embrace factory robotics, to embrace industrial IoT, and most important for ultra reliable, low latency applications. So once you disaggregate the RAN, you pretty much get the power of controlling it. So you're, in a way breaking the distributed and the control part. Again, the control or the centralized part itself, you're breaking into a user and a control plane. So there is a lot of flexibility. Suddenly, you get where are your connected cars on the road? Can I build a mini Telbeast closer to it? And that's where your little, mobile or multi-service edge compute happens. So you make decisions locally, you analyze them, and you just push the data back. There is no reason to traverse the whole cloud. The cloud-native 5G core for Rakuten, this is just an example. It will pretty much be the same, even for Reliance, Jio now as we speak. For people following, I think the announcements, it's very close to home.
Did we lose Subodh?
Yeah, seems like we have lost Subodh.
Yeah, I can't hear him as well.
I think we lost him.
WANs, whether we call enterprise networks, whether we call IoT, or smart cities, connected cars. Hey, Anita, sorry, you had to say something?
No, can continue.
Okay. All right. Yeah, I can just see the time. I'll just probably summarize on this slide. It's just 21 minutes. So can I go for 4 more minutes? Is that okay?
Go ahead.
Yes, Subodh.
Okay. All right. So just summarizing, right? Irrespective of the 5G, IoT, or whichever way you look at private or hybrid clouds, sure. This is what you really have inside the company, running, managing, implementing, or engineering those clouds. You're going to have all this, I put this as boxes just to tell you what the life cycle goes about, but you need automation at every level for this, okay? And it all needs to be in simple English. It has to be a feedback loop, right? There is no point in just, people admitting more people on the network and not knowing how the network is failing, what's happening. So the planning, design, implementation, not talking to these various teams. Change automation for IT is a big one for people from Cognizant, TCS, Wipro, Infosys. This happens every day. Software people have to change, have to manage the release, validation, benchmarking. A lot of this happens only when you have insights. Can I introduce a little change, monitor the what-if condition, and then go for the massive change, right? So all these what-if scenarios, need to be part of this. The development world, the IT world, the networking world, right? Honestly, for all of them to really be self-driving, whatever we may imagine as self-driving, it's very critical you start with a simple layer. Like, what infra do you have? What outcomes do you want? Do you want to onboard, say, for example, 7,000 users every day on a geo network, just giving an example? And what are you missing today, right? What is a delta which you don't have? So it's very critical you kind of list the ABC down, and that's what really takes you further, really, in your DevOps earning. Networking, as we speak, is getting cloudy. SDN, NFV, 5G, a lot of these concepts are coming, and I just thought I would have of sharing this use cases and this journey statements with you. So hopefully this was useful for all of you. Very open for any questions in the QA panel for me.
There is one question. I'll share it with you, Subodh. So there's a question: are there any open source available to translate the young models to C, C++, or Java or Python language?
Yes, absolutely. Great question. If your question is more around looking at young catalogs, you could just go and Google for young catalogs. Every vendor I know, proprietary, half proprietary, fully open, from the edge core, Arista, Huawei, Ericsson, Nokia, Cisco, Juniper, everyone have put their young data model libraries. So it's all open out there. Just go and Google for young catalogs and you should be able to get it.
Just to add more, I think the question was more about translating the young models to the programming language, like creating the APIs. As I know, Cisco has a project called Cisco DaveNet, which can do this job.
Oh, that's true. Sure, absolutely. So if you type developer.cisco.com, that's our DevNet community. Over, I think, 10,000 of us developers. We actually support all these technologies I mentioned stock. You could similarly go to developer.amazon.com or developer.google.com, right? So every company will have a DevNet zone, but either say developer.cisco.com, go to that community, select IoT, select 5G, select whatever you want to, and you'll get all the libraries there. You can go down to the traffic light sensor you want to be implemented for your smart city. You could go down for the 5G network just for change or policy automation. It's all supported. But yes, developer.cisco.com would be your DevNet zone. We also have certifications for people who want to prove their learning merits. Just like any other Cisco certification, it is valid for 2 years. So you are highly encouraged to join the community, contribute to it, using your approaches or whichever technology you're comfortable with.
Thanks, Subodh. It was a wonderful session. So next I would like to invite today's last speaker, Avinash Bhatt from Samsung. So Avinash, I'll share the presentation for you.
Yeah, thank you, Dwarka. How much time do I have? I'll try to keep
20 minutes.
Okay, I'll try to wrap it up in 20 minutes because I think I get to say the final word on ORAN here, and I think a lot of things have already been spoken. But I'll try to kind of keep it to 20 to 25 minutes. So I'll try to wrap it up by 1:30. Is that okay?
Yeah. So I have shared the slides. You can go ahead.
Thank you. Thank you, Dwarka. I think if you could go full screen, please. Yes. Yeah. Thank you. Thank you very much. Apologies. I think there was some hiccup on my side earlier, and we couldn't go with the flow which we had planned. I think the whole discussion was flowing quite well, with Kasif playing a very good overview of what ORAN is about. And I wanted to kind of deep dive into the intelligence framework and also why this makes sense, why open source in telecommunication makes sense today, and why it was like, these kind of concepts were there a few years back, but why is it taking a lot of prominence today? I think I just wanted to stress upon these aspects today. So maybe if you could go to the next slide, Baka. Yeah, so this, I'll not spend a lot of time here. This is the why part of it. So today, the operators who are ultimately going to implement this whole solution and who are going to kind of ultimately deploy the telecommunication networks, they're under a lot of pressure. So there is this exponential growth in consumption, which has been going on for the last decade, and it's grow. So by 2025, we are expecting it to go to 28 GB per month, which is about 4x time of the consumptions of today. We are already seeing this in the Korean market, where 5G has been introduced for a year and people are consuming around 28 to 30 GB per month. That's one part of the trend. So coming to how much a GB per user is priced. Globally, it's about $1 to $5, and in a country like India, which has massive demand, the GB cost is just 9 cents. So if you look at purely from an operator perspective, they are pressed to support a lot of demand, whereas the revenue which they can generate is coming down. And to add to that, we're talking about 5G, new services, and we're going to target new verticals, autonomous cars. We're looking at smart grids, e-health. So I think from an operator perspective, the key thing is operational efficiency. So I don't think, the main objective, and I think as Dwarka started off the session today, he mentioned about there should be a goal. So the whole goal, I think, for all of us, I think whatever has been covered by Vinay as per what the cloud native is going to offer, or what autonomous solutions which are coming up on the core network side, I think that the main focus is to come up with operational efficiency. And that's what we're working on and working towards. Next, please. So if you kind of zoom in into the operator's network, today, and I think 60 to 65% of the total cost of ownership is in the RAN domain. So this is a domain which I think all the topics we spoke about so far has been agnostic to it. It has been purely monolithic software. Typical RAN domain actually has basically access units which are deployed around the city, and there is a baseband unit and there's a radio unit. That's a typical deployment scenario, which is by itself a distributed architecture, and from the baseband unit it's connected over a standard open interface towards the core network. So there is some sort of openness in the standards, in the sense that the interfaces are standardized, but within the RAN domain, it has been hugely it is monolithic software, proprietary hardware, and this, by the domain itself, the real-time nature of the traffic it handles is extremely sensitive. So it is that much more harder to virtualize it. But I think there has been a lot of drive to take it in the direction of virtualization, and this concept of moving to virtualization or kind of centralizing the baseband is also not new. But for example, China Mobile has already kind of centralized the baseband unit, and they have deployed it, and they're seeing some benefits of kind of moving to cloud kind of architecture. They have experienced about 25% capex saving and more than 50% opex saving. But virtualization by itself does not mean open source or openness, because the whole interface which binds this whole RAN is still driven by proprietary software. So the general mistake which typically happens is people try to kind of interchangeably use virtualization, cloudification with open source. I mean, those topics are driven by open source, but from a RAN perspective, much more is required. For example, the CIPRI interface, which is connecting the RU to the BBU, So that is almost all deployments in the world today are using this interface, and it is driven by proprietary communication. And this interface by itself has its own challenges. Just to give an example, today in a geo network, if the base station is giving you about 150 Mbps of speed, and the RU is kind of processing this, and it typically uses IQ samples for communicating between the RU to the PBU. So the communication itself will be about 2 Gbps. So that means if I were to separate it in separate entity, the amount of load it would add in the transport network is enormous. So that I think was the first target of moving towards a scalable and next slide, please. Yeah, so I think what is open about Open RAN? I think so disaggregation is one part. I think disaggregation is important, and I think that is dealt with as part of the architecture. So 3GPP by itself has come up with a CUPS-based architecture, which is I think which Subodh talked about, where you're separating the control plane and user plane. This is very important because separating the two planes is very important for better management and for automation. But there are parts of the RAN which are very difficult to separate, and so in terms of disaggregation, basically the whole RAN is now broken into T components: the open radio unit, the open digital unit, and open central unit. So kind of the whole 3GPP stack, which was managed within one software. So that has been broken down into these components, and they are now connected to open interfaces. I think by openness, when we talk about Open RAN, it's mainly driving these interfaces. For example, the F1 and the F2 interface, which I've depicted here, is what is the main focus of Open RAN, and this is driving a lot of interest. At the same time, the virtualization brings its own benefit. So if we put this together, that is where I think an operator can derive much more benefit. So virtualization by itself provides some benefits, and when you bring in disaggregation and openness, I think that adds a whole new dimension. Next slide, please. Yeah, so I think as already spoken earlier, I think Dr. Alok covered the entire open source spectrum, and there are many people focusing. I'm mainly talking only from a RAN perspective here. So there are many initiatives. There's a TIFF initiative, and that's the Open RAN term which comes up. And ORAN is the TIFF community. The focus is always to kind of drive the whole thing as a project and try to build awareness. The importance of openness in RAN is what the main focus is. But the nitty-gritty, the bricks which build this whole open interface is driven by the ORAN, and I think all the specifications, whatever, and in fact most of my presentation is going to be around ORAN. Of course, the small cell forum also has been doing its bit. The FAPI interface which they have come up with is also quite important. And when we are disaggregating RAN, what used to work together well in one box is now getting is going to get into different components and potentially deployed by different vendors as well. So it is very important for the transport network to be much more efficient. So that puts a lot of pressure. As I said, just to radiate about 150 Mbps on the radio interface, you might need a transport of 2 Gbps. So that puts a lot of pressure on the transport network, and transport by network itself has to evolve. So the ONF forum has actually come up with SD-RAN this year, and that will work hand in hand with the ORAN Alliance. So a lot of initiatives around this Open RAN space, which I think are very important. But is it going to be successful? Next slide. Yeah, so in my opinion, I think Kasif did talk about it, this already. But I just like to stress on a few points because I think so there was virtualization, which gave us some benefits, open interface, and I think most of the discussion today in the Open RAN or ORAN community is around the F1 interface or the fronthaul interface, where you're kind of separating your RU from the DU. I think that is getting a lot of focus. Just to kind of emphasize on that point, today there are about 75 companies who are in the voting rights for that particular interface alone. Kind of gives you an idea of how many people are really interested. So I think in terms of strong industry partnership and ecosystem, I guess a lot of new players are already there, and they're working towards. So the specifications are there. There are some challenges, I guess. Kasif already covered it. I'm not going to touch upon it again. So there are some challenges in terms of which profiles to use, etc. But they're all there in the specifications. So it is up to the operator who's going to implement this to kind of mediate that and identify which solution. So that's definitely one important aspect, and I think that is pretty much in place. I think there's a lot of interest, and I think by the operator. So it definitely that interest is there. And when we have disaggregation and we're bringing in so many different players, so putting it together, so multi-vendor IoT is going to be critical. So I think this is some place where I think a lot of work has to be done, and putting it together, the SIs are also going to play a very important role. So these guys have to put in the solution together, and the challenge today is from an end user perspective. I mean, all this open source, etc. is very interesting, but from their perspective, they expect the same kind of service which they're experiencing today. Whether I'm using open source or the monolith software really doesn't matter. So putting this whole different aggregated solution and giving the same performance is going to be very challenging. And for the people who are managing this entire network, it is extremely challenging because now there are more components, and every node getting introduced into the network means another point of failure. And putting it together, deriving that same performance means that we need to educate the people on the operator side, and the complexity is really going to go up very high. So that is where I think the openness and open RAN is very interesting. But if you do not talk about automation, and I think it was very well covered by Subodh, the importance of automation. And I'm specifically talking from a RAN domain as well, because if they do not go hand in hand, I think this whole thing is going to fall apart. And I think that is where a very important, I think it's very important for automation to be dealt with together with this open interface. So the next slide, please. This is why I think it was very well covered by Subodh, but I'm just going to touch upon it again. And this is how probably a future deployment of operator networks are going to look like. I'm mainly focusing on the RAN domain again here. So we have the ORU, which is likely to be a physical network. I mean, since it's got passive elements, antennas, etc., it's very unlikely it's going to get softwareized anytime soon, or it looks almost impossible at the moment. So we can expect that to be kind of the physical entity connecting to a ODU, which I think can be containerized, as when I talked about, or it can be a VNF. Different operators are going to have different combinations, and some might choose just to go with the physical network, the existing distributed architecture as well. Then we have the DU, where I think the CU, where most of this RRC kind of handling happens, and all this put together kind of will be the RAN. So now, because there are a lot of virtual components and the software can be managed automatically, so I think there's a lot of opportunity for increasing the efficiency of the underlying hardware, and they're all running on general purpose hardware. So I think that is, for example, today when Reliance Jio deployed its network, they had no choice but to kind of provision up to 50 million subscribers and wait for that capacity to be fulfilled. But in the future, operators might not want to do that. And I think it is very important for them to build the network as they grow. So I think that is where automation plays a key role, and I think openness and open source in communication is very important, and I think automation is the key for operational efficiency. So another important point is all the nodes. We keep talking a lot about the open front hall interface, and that's where rightly a lot of interest today. But a lot of these entities which are getting deployed and managed, the management entity is entirely proprietary as well. So it is very important that management interfaces are also open. The service management and orchestration interfaces are open, and that's when we really see all those challenges, which I think some of them touched upon by Kasif as well, where we have the open radio, and deployed from different vendors. Ideally, if you go by the current scenario, all of them will bring in their own NMSs for management. But if they're all powered by an open interface and open management, I think it's going to be a lot easier for an operator to manage, and I think that is critical for the operational efficiency which an operator is looking at. So then automation can happen at different levels. So in terms of managing your resources, like I think physically cloud resources, your capacity, your service. So all kind of automations are possible. So I think that is where I think if you go to the next slide, please. So I would like to talk about ORAN again from this whole broader perspective now. Actually, I think when you talk about OpenRAN or ORAN, people talk a lot about the front-wall interface, but it also has a very well-defined intelligence framework. And so, because I think intelligence and openness have to go hand in hand for it to be successful. So cloud scale economics, I think that is already covered because of the open interface and purely because we're talking about virtualized solutions for most of the deployments. So that's typically covered already. So the part I think I will stress a little bit more in the next 5 to 10 minutes is about the automation of processes. And because RAN by itself brings in their own, RAN by itself brings in own challenge, because apart from cloud management, your splitting of control plane, the physical resources, which is basically the spectrum management by itself, is a big challenge. And that brings a lot of opportunity today for automation. And there is the RIC, or radio intelligent control, which has been introduced, which has basically a hierarchical deployment. We have the near RT RIC, which is slightly closer to the RAN domain, and a non-real-time RIC, which is slightly sitting at the orchestration layer, which has a larger purview of the whole network. This kind of forms the entire, so the E2 interface and the O1 interface, which has been defined by ORAN, actually helps to open up the management interface, which I was talking about earlier. So all this put together gives you a very nice framework for improving the overall operational efficiency of the operators. And I think that is where this framework is getting a lot of adoption today. So we in Samsung also believe, I think our interest in Open RAN is also purely because of the same reason that while virtualization and open interface will help drive the cost, those are definitely the key drivers. But the end goal of the entire framework and why we are very interested in this is because of the end goal of bringing in, if the cost reduction will help the wider adoption of 5G and also will enable AI in wireless. Essentially, the key here, and that's our motivation for being very actively involved in the ORAN Alliance. Can you go to the next slide, please? Yeah, so I just have about 5 minutes. I actually want to get into a lot of details on this. So I'm going to deep dive on a little bit on what RAN closed loop automation looks like. The ORAN framework talks about 3 levels. Briefly, I think Kasif did talk about it. Any automation which needs to be within 10 milliseconds has to be dealt within the node itself, which could be anything like to scheduling, beamforming, etc. Something which needs, it's not as time critical, but of course it still has a criticality about 10 millisecond to 100 millisecond, like a handover procedure or a load balancing procedure will be dealt in the near RT RIC. And anything which requires larger or which is not that time critical, which mainly will fall in the domain of orchestration or optimization or like slice SLA management. I think that will be dealt in the non-real-time RIC. So here again, the management plane, opening up the management plane is very critical because the management plane can give you the interface for collecting statistics and putting it into an analytic framework, which is already defined in the Open RAN. And coming up with interesting feedback, which will optimize the control plane, be it through the near real-time RIC or through the NE directly. So in general, I think already there are frameworks. I think Kasubir touched upon it, that already there are SON frameworks, very true, but they're not open. So I think the first point here, which I think is provided as part of ORAN, is that open SON is what is, I think, key for this whole process. So that will enable a lot of automation. This ORAN framework will enable efficient orchestration, and orchestration is something which is very important. Because the interfaces are open, you can manage your FM fault management in a very generic way, and because it will be equipment from multiple vendors, it will enable the operators to kind of do together. And lastly, telemetry and analytics can also be enabled. And I will talk about this with an example. Maybe you can go to the next slide because that will help us understand better. We can skip the slide. You can go to the next slide. Yeah, so this is, so we at Samsung believe that, I think our focus is purely on the operational efficiency. I think we've been quite active on the Open RAN front, and we would like to take an approach where we will touch upon some operator pain points. So this is some work I just wanted to share. Like, for example, today in India, I'm taking India as an example. This is probably true in a lot of other countries as well. But India is a classic case where operators are running at 80 to 100% of the network capacity. So the networks are completely choked. And what it means to operator is like directly, it's revenue loss, because every time a site goes down, per minute they lose about 7 lakh rupees. And indirectly, of course, when the user experience is bad, there will be subscriber churn in the long run. So that itself accounts, and in Indian market, it's quite prominent. That accounts to about $2 billion loss. So network congestion is a serious problem, and if dealt with, will be really important. And I think this is a problem which I think we wanted to kind of address. So, of course, when a congestion happens, and I think operators in India also do that, because the spectrum which they have is limited, and the spectrum auctions or the resources which kind of they get is also quite expensive. So they would like to maximize the utilization. So typically, they either deploy a higher MIMO solution, or a massive MIMO, or could go for a Wi-Fi offload as well. Next slide, please. So like just attacking this problem and keeping the ORAN framework in mind. Clearly, as you can see, there is the whole traffic pattern. And this is just for one cell, and each cell might have its own pattern. It seems to follow a pattern. And in India, I think this is a typical pattern for a metropolitan city. So between, I think in the morning hours, there's hardly any usage because it's also sleeping. The maximum usage happens between 7 to 10 p.m. And that's where the capacity goes. I think it goes to like probably less than 1 Mbps, or even like in few kbps also. So it is this duration where actually there's a problem, and rest of the duration there's actually not much issues in the network. What if I were to understand this? For example, if I just pick up some parameters like the number of users, the resource utilization, and feed this into the analytic framework which is provided by Open RAN, and try to understand the pattern. And this is exactly what we did. And we found that almost every cell kind of follows, and if we feed it with sufficient data, we can predict it. And in fact, we were able to predict with about 90% accuracy. So then we can look at this whole congestion problem in a different way, because while operators are already putting in some measures, for example, keeping a massive MIMO on for the whole day, vis-a-vis keeping it for a few hours when there is congestion, would lead to, I would say, a lot of OPEX saving for the operator, because massive MIMO is known to consume a lot of power. So these kind of optimizations can be sought, and that's exactly what the ORAN framework does. Next slide, please. Yeah, I'm just going to leave a minute here. What I talked about is how we can use this whole congestion in this whole framework. So the information about the few parameters like number of users, PRB, we collect it here, feed it into the ORAN framework. We use an AML framework to understand the patterns, do a model training, and then whatever inference is fed back to the near non-RT rig. And then we kind of use this model to define some policy for mitigating the whole solution. So this, I think this kind of interesting problems can be solved, and I think that is where a lot of opportunity, even for anybody who's participating today, is to contribute to use cases, define a framework for solving some problems. And this was in fact one of the first machine learning problems which was submitted into Open RAN, which we from Samsung contributed. Next slide, please. Yeah, so in general, Samsung has been very active in the Open RAN ORAN Alliance. So we have been, in fact, members of it from the XAN days. I think XAN eventually became ORAN. So in 2017 itself, Samsung was very active. In fact, we were actively contributing towards the option 7.2x finalization. And we then, I think, have been very active throughout. Today, we have co-chairs in WG3, and we are actively contributing to ORAN SC as well. This year alone, we have contributed some 5K. A lot of this is driven out of our office in Bangalore. So there has been a lot of traction on the ORAN front, but other forums as well. Samsung is actually on the board of Linux Foundation, and we've been active members from 2018. With respect to ONAP, we are ranked number 2 in terms of contribution in 2019, and we're still actively contributing there. And even Samsung is also is one of the founding members of the ORAN Open RAN Policy Coalition, which was formed earlier this year. So we strongly believe that open source is very critical. That's the objective, because we understand that operators are looking for operational efficiency, and the intelligence framework and automation is very important, even on the RAN domain, more so in the RAN domain. And I think if we help operators improve the operational efficiency, that by itself will enable faster deployment of 5G. And I think that's which we feel is a very critical aspect. Next slide, please. Yeah, I'm just summarizing my presentation. So I think there is virtualization which is happening, which is very important. That will help operator get some benefits. Open source, open interfaces are important, but I think for us, for the telecom industry to really progress and use this all together, I think automation and intelligence is very critical. And I think that's when the flywheel of, I think this whole new change is going to take off. Thank you very much. I kind of rushed through my presentation, but I hope I managed to keep my time. Any questions? I'll be glad to take.
Yeah, there are a few questions. I'll just pose them. There was one from the YouTube channel. I think this came much earlier. I think one of the key questions is how much are we confident for ORAN after deployment? And I think the user has mentioned that when some vendors are facing challenges in 5G NSA deployment.
I agree, there are some challenges. This is, for example, when you talk about NSA, there is then OpenX2 interface. I think probably people are referring to it. So this is standardized, and definitely, in terms of standard interfaces, almost all vendors support it, and interoperability will be there. But for it to truly work together, I think probably if both the equipments, 4G and 5G equipment, are provided by the same vendor, it works well. That's how it is today. But I think that is where I think we're stressing on the intelligence framework, because I think these problems are coming today because I know the boxes have already a lot of intelligence within them. But if into a higher plane, into an XApp framework, where most of the instructions and the framework of contribution is open, I think this kind of problems will go away. But today, I think the question is right, and it's a very good point that there is open interfaces, but it hasn't been very successful. But I think in the due course of time, with this intelligent framework becoming very strong, I think this kind of problems can be dealt in a different way than it is handled today. Today, it becomes an interoperability IoT problem. But in the future, maybe this can be dealt at the intelligence level, where an app is developed by the operator and he can handle it from his end. I hope I answered the question.
Thanks, Avinash. There was another question on, does ORAN provide the spec for KPI and SLA, or is it the job of the aggregators to decide?
Actually, the KPIs, I'm not sure when I say KPIs, are you talking about statistics, or I'm not sure what has been asked here, but there is a framework provided today, whatever network statistics which are defined, for example, the standard KPIs which are used by the operators today like Jio or anybody. There is a framework defined for collecting this, and once the KPIs are collected, how to use them is up to the individual XApps, but a collection framework is defined, and in fact, some contributed for collecting this KPI into the near-RT link via the interface.
Okay, thank you. And there was another question which I think Subodh has already answered about commonality between eCPRI, ORAN interface, and FAPI interface.
Okay, sure. Okay, thank you very much. I hope I kept the time, and thanks for giving me the opportunity. Thank you.
Thank you, Avinash. So we are at the last segment. I would like to hand over the control to Dr. Alok and IEEE COMSOC Bangalore coordinators.
Okay, thank you very much. I guess it has been long than anticipated. But however, we have done a good job in bringing this whole topic of open source in communications, starting from looking at the trends, the ORAN, the ONAP, and Red Hat Kubernetes coverage. Subodh has done a fantastic job to highlight, the issues that comes in between. And Dwarka, you took it step by step. So it's a first one from IEEE COMSOC Bangalore chapter on this topic, and we will take it forward. And I guess again, thank you all very much. And it's a